Hey, hello everyone. Welcome to DevOps India Conference 2023. And my name is Sangam. I'll be the I'm an organizer and the host for this event. And I would like to first of all I would like to thanks all the participants, and I would like to thanks all the speakers for sharing their knowledge. And this is a third year of DevOps India. This is a free, non-sponsored, non-profit uh, conference powered by CloudNativeFolks community. If you want to join this community, you can see the first comment or in the description of this video. You can join on the Discord, all speakers available there. So you can chat with them, you can ask your questions, and we have a really great lineup of speakers from security to monitoring each and every cycle of the DevOps pipeline. And with me, I have host Sriya. I would like to welcome Sriya on the screen. Um, Here we go, Sriya.
Hello everyone and welcome to today's YouTube Live organized by thanks a lot Sangam for choosing me. It's a pleasure to see you all here on a weekend, and this shows how much passionate we all are about the technology. Let us begin with my quick intro. I am Shriya Madan, working as a software engineer, and I have a experience of 1.5 years in the industry currently. And I'm honored to be your host for this event, and I'm excited to be supporting the community. The CNF community is growing and connecting great tech enthusiasts with each other, and really applaudable work done by the community and you, Sangam. Okay, now let's take a look at the agenda today. So, we are here for interesting sessions on DevOps from speakers across the globe. And let us try keep it interactive throughout today. And feel free to drop your comments and questions in the comment section, and our team will try to answer it. And I'm looking forward to an engaging and informative session with you all today. So let us dive in with our first session on bootstrapping clusters with EKS Blueprints by Samuel Baruffi. And yeah, without any further ado, let us welcome our first speaker. So Samuel Barfi, he's currently working as a senior solutions architect at AWS, and he is also a mentor at Great Learning. So Samuel, he's a tech-driven professional with 15 plus years of experience in IT industry, and currently focusing on helping global financial services based organizations to adopt and modernize using cloud technologies. So yeah, let us see his talk about bootstrapping clusters with EKS blueprints.
Everyone. Um, my name is Samuel Baruffi. I am a solutions architect with Amazon Web Services, also known as AWS, of course. Um, I work on the global financial services organization within AWS, helping financial services companies on their cloud journey. So really excited to be here today and present my topic for all of you on this event. I just want to say a quick thank you for all the organizers for giving me the opportunity to be here. And what we're going to be talking today is how can you utilize EKS Blueprints to bootstrap and manage your EKS clusters, not only the clusters itself, but also applications within the clusters. Just a quick information. If you're not very familiar with EKS, some of the content might be a little bit unfamiliar for you. So this requires a little bit of knowledge on Kubernetes, specifically on the managed elastic Kubernetes services, which is also short, which EKS is short for. So without further ado, let's just take a look on the agenda that we're going to have today. So first, we're going to talk at an overview why have AWS within the open source community built this EKS Blueprint solution. Why is that important? Then we're going to dive deep a little bit into what is EKS Blueprints and how can help you and your organizations. We are going to go back and look from customer feedback that actually made EKS Blueprint became a tool. And we're also going to talk about GitOps. So EKS Blueprints does a lot of things, and one of them is you can integrate very well within your GitOps ecosystem. We're going to talk about what that means in a high level. And then before we end the presentation with a demo, I'm going to share some resources. And if there is one thing I could hope for all of you that are looking, watching the session, is that you just navigate into the GitHub EKS Blueprints repository, and that you can actually, read a little bit, understand the documentation, and try for yourself. It's actually really straightforward to try EKS Blueprints using some of the infrastructure as a code tools that we're going to talk today. And finally, in the end, we're actually going to spend some time doing a demo, very simple demo, because I don't have a lot of time on today's session. So I'm just going to do a quick demo showing how you can deploy EKS using EKS Blueprints with Terraform. And of course, we're going to talk about what that means in a moment. So I want to start just to put some numbers on how important the Kubernetes ecosystem and open source community are. The numbers you see on the screen are for 2021 because the Cloud Native Compute Foundation haven't yet released the results for the 2022 survey. But pretty much when you look back with the growth of Kubernetes, we could see that 2021 and I'm sure 2022 kind of showed similarly strong numbers. That 96% of our organizations are either already using Kubernetes or evaluating to use. And that's a pretty big number. Only 4% of the organizations are not considering or using. So you can see the power of open source community and how popular containers and containers orchestration are. On the same server, 5.6 million developers are using Kubernetes today. And that's a 67% increase from just a year ago in 2020. And out of all the Kubernetes that are deployed out there, and of course, given the data samples that Cloud Native Compute Foundation has collected, 39% of those clusters are EKS, which translates to, for EKS, to be the most popular managed Kubernetes service available right now. If you're not familiar with EKS, I know I mentioned that you should have some sort of knowledge to make use, good sense and use of my talk today. But EKS is the managed service from AWS that allows you to deploy and run Kubernetes clusters at scale, and a lot of the operation burden that you need to do if you're running your containers on Kubernetes on premise, or you're managing your cluster yourself, are taken care by EKS. So it's a fully managed container orchestration. There are features that are being release every couple of months or even every month that increases the performance and capabilities that EKS provides. So let's just quickly spend maybe a couple of minutes talking about, when you're choosing the platform as Kubernetes, we need to be honest as Kubernetes folks that the learning curve is really steep on Kubernetes. It's not something that you can just throw a new developer, an engineer, on a Kubernetes cluster and expect that person within a couple of hours to figure everything out. Kubernetes can be very complex. And this diagram that you see, this image that you see on the screen represents that in a very good way. So you have the control plane that you need to think about. Within the control plane, you need to manage the etcd database, data store. Then you have the API pieces that the control plane needs to manage. You have the schedulers, the controllers. So there are a lot of moving pieces just on the control plane, right? Thankfully, EKS or other managed Kubernetes will take care for you about that piece, so you don't need to worry. But even when you don't need to worry about that, now you start talking about like what we call the data plane nodes, right? So where actually your containers are going to be running, and those are these specific box here. Within the specific box, you have a kubelet that communicates back to the control plane, and then you have the kube proxy. And you need to make sure you are scaling your Kubernetes to fit the demands of your organization. So maybe you have a very spiky workload. What are you doing to scale both your pods but also the nodes behind the scenes? So there is a lot of things that you need to understand in order to take the full benefit and the flexibility of Kubernetes. So when we look on the journey of using EKS, which is a managed service, we provide a secure and scalable solution that will manage that for you. So what that actually means, right? First, we manage the data plane. First we manage the control plane, which is this box here that is running on AWS environment. You don't have visibility. We just provide you with an API, Kubernetes API endpoint, and automatically behind the scenes, AWS will scale the control plane based on the demands you have. What you need to do is you have a flexibility is configuring the data plane, right? So data plane with EKS, you have many different features that you can choose from. You can choose to use potentially manage node groups, which as the name says, it actually manages the auto-scaling group and the configuration of those EC2 instance behind the scenes for you. So when you need to do an upgrade to a newer version of a Kubernetes and EKS, you can actually both hand that job and that operation burden to AWS to manage the control plane upgrade, but also when you're talking about the data plane upgrade, you can actually just ask AWS, when I say ask, is send an API call, say, hey, please upgrade this data plane server by server in a rolling mechanism so you don't face any sort of disruption and outage on the applications that are running within the cluster itself. But that is just scratching the surface of the capabilities of what EKS data plane gives you the support. You can actually configure spot instances if you can handle interruption. Spot instances are just a cheaper version of EC2 instances that AWS makes available for folks and organizations that can, that are willing to pay less for the EC2, but once that EC2 needs to be put back on the on-demand pool, you just get a 2-minute warning and that gets removed. So the whole idea of Spot in a simple term is AWS, there is always some spare resources available on the cloud. And because those spare resources, is just cost for AWS, makes those EC2 instances much cheaper for folks to use. On the negotiation that once AWS actually requires that those resources back to on-demand. So let's say another customer is actually trying to request an on-demand EC2, then you get a 2-minute warning and that interruption goes on. But that is outside the topic of today. If you're curious about Spot Instance, just Google AWS Spot Instance and you see that there are a lot of coverage across many AWS services. But it doesn't stop there. When you are actually, so you've done the job of understanding Kubernetes, you've chosen EKS as your Kubernetes orchestrator, you've chose how you want to manage your data plane and data node groups, right? Let's say you want to use manage node groups, so AWS also manages that piece for you. But now, finally, you start talking about which tools and applications you want to deploy within that specific Kubernetes cluster. And when you start to realize the Kubernetes itself is not really powerful, you need to tie that with a lot of add-ons or functionality or services that will make that happen. So as an example here, well, if you want to use CloudWatch, you probably need to install some CloudWatch services within your Kubernetes. You want to use the VPC CNI to integrate your Kubernetes network with the VPC network on the AWS. You want to make sure that you can deploy load balancer automatically when you are doing a deployment, and also a service, Kubernetes service attached to it. So you need to have those add-ons deployed. And that takes a lot of effort, configuration, and it's not really easy to automate on day 2. So those are the things that you start to think about, the operational challenges you face on day 2. So day 2 means once you have deployed your Kubernetes and you start to operationalize and productionalize your Kubernetes, what are the things you need to be aware? Well, first you need to know observability, like which tools are you collecting logs, metrics, and traces. Here you have some examples of open source tooling like Prometheus, FluentD, OpenTelemetry, just some examples. But you might be using a third-party vendor like Datadog, or you maybe are within the AWS ecosystem with CloudWatch. You still need to have that configuration between your Kubernetes clusters and the vendors configured. Then you start looking at delivery. Well, are you doing any type of GitOps? So if you see here, you see Argo CD and Flux. Those are actually GitOps open source tooling that are part of the CNCF Foundation. But you might also want to do crossplane. That allows you to actually use the Kubernetes as an infrastructure, as a code to the cloud, right? Like let's say you want an RDS, you can call crossplane, and crossplane can actually on your behalf create the resources within the Kubernetes, but also outside the Kubernetes. But then you start talking about reliability. Well, I really need my cluster to be scale and flexible on demand. So you can deploy tools such as Carpenter, which is a open source tool that AWS released to make it very easy and much more flexible than, for example, Cluster Autoscaler can do. So just as a plug here, if you're using EKS and you are still using Cluster Autoscaler to do horizontal EC2 scaling, take a look at Carpenter, because that gives you a lot of flexibility. So you can just put Carpenter EKS on Google and you find a lot of documentation. But then it doesn't stop there. You need to do a lot of the security configuration. So maybe you're using Gatekeeper as your open policy gateway. So you deploy a lot of security driven approach, so like a DevSecOps approach. Or maybe you want to do some Cilium network policies, or you're integrating with Secrets Manager, where you're storing the secrets. You don't store any secrets within the Kubernetes. You actually want to externalize those secrets. You can use Secrets Manager. But everything that you see here, and then you see the others, it's a vast list of things that you need to think about it when you try to productionalize your Kubernetes clusters running on EKS. But that's true not only on EKS, on any other cloud provider or managed Kubernetes that you have. There are other things that you should think about. It is, well, normally that's not true in every single scenario, but normally you would think about a multi-tenant approach for your Kubernetes cluster. So how are you, how are you doing authentication authorization for the developers? Do you have different separate roles for, admins and developers? How are you treating policy management? How are you doing security management? Are you treating, namespace as a service, meaning that each specific team or maybe each specific workload will get a specific namespace and it can only deploy within the namespace given the specific restrictions of how much CPU, memory, and compute and storage you want to make it available? You need to have those considerations in mind. So those are all the day two things that are hard to think about it. And when you put this image, which is just a mind-blowing Cloud Native Compute Foundation cloud map of all the open source functionality and tools that are available into this ecosystem, there is no shortage of amazing tooling in the Kubernetes ecosystem. But it is really hard to get guidance on how you pull all those pieces together. If you're a Kubernetes engineer, I'm 100% sure you've been in this seat before where you really want to try to do something else with a new tool. Maybe you want to deploy Prometheus, but you want to integrate Prometheus with your cloud provider. How do you actually do that? You probably need to spend a couple of days reading documentation, trying on your sandbox account, and that is really time consuming. And sometimes it's frustrating. So given all the the concerns and challenges we see, we've actually collected a list of feedback from our customers on this specific topic. So what we hear is, how do I integrate EKS external services like manage Grafana and Prometheus into my cluster? How do I actually do that? What are the sensible default for best practice on EKS cluster? AWS makes available best practice white paper for EKS, but how do you have enough resources to actually implement of those? Wouldn't it be easier if you could, consume some sort of automation that would have that in mind? And not everything. You always need to put some thought and configuration yourself. But wouldn't it be actually good if some boilerplaters were already thinking about that for you? And then the list goes on and on. How do I integrate my external IDP to manage my cluster access? Well, let's say I'm using Okta. How do I actually integrate, with my OpenID connector, Okta with my Kubernetes? How do I configure? And I think this is one of the most important ones that a lot of companies have these challenges, at least that I've seen in my time here at AWS. How do I configure EKS cluster to run workloads for multiple teams? So we are talking here about multi-tenant, right? A multi-tenant cluster or multi-tenant clusters. Then again, how do I build an EKS clusters that meet, security and hardened guidelines, right? That is a very, very big challenge. How do I do that? And can I bring my data analytics workloads on EKS? So those are all the challenges we've heard from our customers. And what we've done is we work backwards from there. So we decided to create a flexible tool. So some of the requirements for, after hearing from our customers on AWS, we always work backwards from customer, feedback. So aggregating what we just talked about is we need a flexible tool that allow customers to easily deploy and customize EKS clusters to meet specific and unique requirements. It needs to have out-of-the-box integration with popular AWS services and also open source tools. And the start point for a net new development team to do experimentation on containers needs to be really small. Like I said, you don't want to spend 20 days, not 20 minutes, just learning about EKS documentation. You want to get the ground running and just experience for yourself if it is the good fit or if it's not. And also, we wanted to create a foundation that allows for customization and expansion over time. With that said, here EKS Blueprints was created. So EKS Blueprints is an open source framework that allows you as a customer or individual to configure and deploy complete EKS clusters. There are two flavors of EKS Blueprints. One that is based on Terraform infrastructure as a code, and another one that is based on CDK. CDK is the Cloud Development Kit. If you're not familiar, please Google. It's just a way that you can use programming language, to deploy infrastructure as a code on AWS. Another pillar is all those. This framework needed to be based on best practice and recommendations for EKS. It needed to integrate with popular Kubernetes tools and services. So if I need to deploy, let's say I want to deploy a Kubernetes clusters using EKS Blueprints that has integration to AWS Secrets Manager, Calico Network plugin, and Prometheus, this tool needed to give me a way to do that in a simpler declarative way. And also, which is kind of the power, I guess, of this open source framework, is it needed to be fully extensible and customizable. So you would invite the community to collaborate with us, but also if your organization wants to do a lot of customization that is only for you internally, it gives you the framework on how to do that. So like I said, you have two different open source repositories. One is called CDK EKS Blueprints that has all the information for you to use EKS Blueprints with CDK. And the other one is the Terraform AWS EKS Blueprints that, as the name says, if it asks you to, not asks you, it's for people that want to use Terraform. For the demo, I'm going to be using Terraform today, not CDK, but I'm going to give you some resources that you can just play around and deploy yourself. So when we look at EKS Blueprints, there are four main components that are part of the EKS Blueprints. The first one is the cluster management. And the cluster management is really simple. It's the idea that EKS Blueprint will go create and deploy your EKS cluster based on best practice. And it can easily replicate that cluster. So if you need to have multiple clusters within a region, you can actually use that functionality because it's just infrastructure as a code. And one of the important pieces we heard from customers, it needs to integrate with existing VPCs or leverage a solution that part of the infrastructure as a code and automation goes and it deploys a new VPC. So that's one piece, is the cluster management. You get a cluster up and running for you, with a few commands running Terraform or CDK. The second one is add-on management. One of the pillars that we talked about is you want to have an ability after you've deployed your Kubernetes clusters that this automation goes and deploy all the tooling that you need. So like, Prometheus, CloudWatch metrics, the EBS CSI integration, the Secrets Manager CSI integration, and so forth. So it goes and deploys that for you. The third one is team management. So there are two different personas that EKS Blueprints provide you, an administrator and an application owner. The administration will be that person from maybe a cloud team or a DevOps / platform team. They'll have full control within the Kubernetes cluster. So you can do a lot of the actions that a administrator would do. But it also has support for application owners. So maybe developers that you only want to give access for a specific namespace and specific permissions, will translate and automatically integrate that with your IAM on AWS. So that's another popular thing that EKS Blueprint does. And then the fourth one is the workload management. So it leverages GitOps tooling like Argo CD that allows you to fully integrate it within your EKS, within your Kubernetes ecosystem by using Git. I'm going to talk in a moment what GitOps is if you're not familiar, but it will be good if you already have some familiarity with the concept. But the idea is it allows you, by deploying the add-ons of Argo CD, and in the future we're going to have support for Flux as well. You can deploy Flux manually, of course, that it has that integration for you. And there is actually a self-service onboarding for new workloads via pull request. So there is a new workload, you can create a pull request, behind the scenes, because GitOps can manage both your cluster and the workload. It can do that automatically for you, just within it's someone that is reviewing the pull request up, clicking and applying. So when you look at the solution, the cluster, EKS blueprints to deploy, the EKS, the EC2s. If you need Fargate, the serverless containers, will do that for you. And if you're using Outposts, it can also talk with Outposts. Once it does that and it creates the infrastructure, the necessary infrastructure, you go and deploy all the add-ons that you have chosen, right? So whatever add-ons that you have chosen, you go and deploy. And then finally, you actually deploy the specific permissions, namespace, and specific restrictions that you have defined as part of your teams. So the customer benefits you get is you get a lot of speed because it's all of your automation. It's maintained by AWS, so it's an open source system, but it's maintained by AWS. The add-on libraries are always increasing, and we, of course, welcome people to contribute to new add-ons via pull request on those GitHub repositories that I just showed you, where there is Terraform and CDK EKS blueprints. It's very auditable because everything now is going through infrastructure as a code, and you're storing Git. You can have a lot of functionality to put security in place. Very flexible because it's just declarative with Terraform and CDK. And is also self-service. You get a lot of, the platform engineering gets a lot of benefits because they can configure EKS clusters with multiple Kubernetes add-ons that are available for customers like developers to use. They can deploy across multiple accounts and regions. It's very easy to upgrade. So we know that an important piece of your Kubernetes story is how you treat and manage upgrades on the cluster. So every time there is an upgrade, you can use EKS blueprints to do those upgrades for you. Everything is infrastructure as a code. So all deployments could be powered via GitOps, and that's our recommendation. And you can deploy anywhere EKS runs, including regions, on-premise, and outposts. So we have EKS, which is the managed service on AWS regions. You have EKS Anywhere, which is an open source way to deploy EKS anywhere in other cloud providers, on-premise, you name it, or even on outposts. So we talked a little bit about GitOps, but what GitOps, for folks that are not familiar, is that you are treating everything from configuration to references to environmental variables, not actually the secret. The secret you want to externalize in a secure way, to code, to documentation in the GitOps. All belongs into Git, right? So if you look at this diagram, a developer commits a new application code to the source control. Then the CI server will build and test and scan for potentially some issues, and it pushes a container to a registry and updates a Kubernetes manifest in another Git repository. And Argo CD in this example, which is a GitOps tool, will actually detect that there is a change on that specific Kubernetes manifest, and you deploy whatever application needs with the new container version. That's simply, in a very simplified way, what GitOps brings. The principle of GitOps is everything, entire system is described declarative, is version control on Git. All the approved changes are applied automatically, after a lot of testing. The software agents continuously ensure correctness. So you all have those agents running on your Kubernetes that are checking for new updates and making sure every latest versions or the version that you want are deployed within your environment. And actions are taken on a closed loop between declaring a specific change and that change automatically taking effect. So pretty much EKS blueprints come with Argo CD integrated by default. And if you're not familiar with Argo CD is a cloud native compute foundation that is an incubated project. Argo CD consists of three main components. You have the API servers, API server that gets deployed within your Kubernetes, of course. So it's a set of APIs that are consumed by the users. You can have a web UI where you can see all the GitOps functionality that you have available. But then you have the repository server. So that is an internal service that manages the connection between Argo CD and the Git repositories that are holding the application manifest or the infrastructure manifest. And then you have the third piece, which is the application controller. And that's just a process that actually monitors for every single change that you have on the Git repository, and you make sure that is the same on the target state. So if you have a Kubernetes object of a deployment that you're using GitOps, and that manifest is saved on GitHub. The application controller will always be checking to see if any change happened there, if it needs to do an upgrade, an update on the specific objects that you have on your EKS or Kubernetes. You can manage, we talked about managing application with GitOps, but you can actually manage your cluster. We are not going to have time today to discuss about that, but you can use GitOps to manage all your clusters. So you can treat all the declarative, EKS Blueprint coding as GitOps, and then have a centralized cluster that actually will go and deploy in new clusters and make changes to other clusters. So you can actually not only manage your application on GitOps, but also your clusters on GitOps. And there are examples that are available as part of the solution. Here are just some specific documentation we want to provide to you. We have, like I said, there is EKS Blueprints for Terraform and EKS Blueprints for CDK. There are, quick starts guides that you just click and you get redirected to the GitHub open source repository. But also what we recommend, if you're new to EKS Blueprints, go to the workshops. They are available, for anyone to use. Just a very nice documented step-by-step how to use both CDK and Terraform. What I recommend as well, each repository, CDK and Terraform, will have a example folder that gives you a lot of, boilerplate and a head start. So let's say you want to deploy a EKS cluster with a new VPC, you can actually do that by choosing a specific example. Or let's say you want to use EKS Fargate cluster. How do you actually deploy that? How do you actually declare that using Terraform, EKS Blueprints, or CDK? And of course, this will you keep increasing more and more functionality. There is a blog post, if you just Google Bootstrapping cluster with EKS Blueprints, that was last year in 2022. It goes into more a high level what I just talked. If you want to read it here in your own time, it's a very good idea. Here, I'll pause for a moment. Please take a picture, or just pause. You don't need to take a picture because you're watching this on YouTube. You can just pause and copy. These are the GitHubs and documentation for Terraform, CDK, and also the specific workloads and add-ons managements that you can do with GitOps. So with that said, we are gonna jump into a demo, a very simple demo. The demo is just gonna be how can we deploy a EKS cluster with some add-ons and some other configurations using the Terraform version. So I'll just switch to the demo now, and we're gonna continue the presentation. So okay, going on the demo, here I just wanna show you the different repositories that I showed during the presentation. So we are not going to do the demo today for CDK, but if you go into this repository, Kickstarters, CDK, EKS Blueprints, you can see all the information. You're going to see both on the Terraform and the CDK that there is actually a getting started guide. So if you click on the getting started guide, you see this documentation. So it's very well organized, and it's open source. So you can see, the core concepts, how to get started with CDK. We're not going to do that for CDK. What I want to show you is the Terraform. So if you go on the AWS-IA org on GitHub and you navigate it into the Terraform-AWS-EKS-Blueprints, you can just Google that. You'll find the specific, URL. This is, the most important piece of code and documentation that you want to be familiar with. So similar that you saw on CDK, we have a getting start guide for Terraform, so you can click there, but also you can just look at the README here, and README will provide you with some informations, especially with the examples. So I'm going to open the examples and show you, and also open the documentation. So when you look at the documentation, it's important to look at the getting started first. So what you need to deploy Terraform EKS Blueprint is you need AWS CLI. Of course, you need an AWS account, and you need to have access to the AWS CLI on that account. Either using access keys or some sort of SSO, depending on the organization or AWS account that you have, and you need to have Terraform installed. So if you can click on those links, get that installed. And then in this page, just do a very simple example, not simple example, it does an example of creating a specific EKS cluster in a new VPC. So you can see the new VPC. And it also deploys as part of add-ons this add-on. So the load balancer, cluster outscalers, and so forth. I'm not going to use this example for my demo, but what I'm going to show you before I jump into the demo is the core concepts. If you remember what I talked to you about the core concepts of the cluster, add-ons, team, and applications, those are described and explained here. The pipeline is something that is available on the CDK EKS Blueprint, and it's being worked on more integrated on the Terraform. As an example, if you want to see how you actually create different teams, and I mentioned that there are the application teams and the platform teams, you can look at the documentation and you provide a specific guidance for it. And I'll actually do an example for you in a moment. The add-ons, so if you click on the add-ons, you see the list here on the left with all the add-ons that is currently being supported on the Terraform for EKS Blueprints on the version 4.21. This list keeps increasing, so if you want to contribute, you have some add-ons that are not there and you are willing to contribute, just go on the Terraform for EKS Blueprints and you submit a PR. There are workshops that teach you. The workshop link that I showed on one of my last slides before will show, there will be a module that allows you to create your own add-ons. So, and of course, the community is very vibrant and allows you to collaborate with other folks and get that started. If for example, you can click on, we're going to do an example of deploying Chaos Mesh, which is an open source chaos engineering platform. You can see that in order to deploy, it's as simple as just literally deploying, declaring enable chaos mesh equals true on part of your Terraform template. But optionally, you can also pass specific configurations like the version of chaos mesh. Behind the scenes, most of these add-ons are actually managed by Helm. So what the EKS Blueprints is actually bring a specific Helm chart, and in this case you can see where the repository of this Helm chart is available, and deploy for you. So it's managing. There are two types of EKS add-ons. There are the native EKS add-ons that are managed by AWS, and I think there are 5 or 6 currently supported, which are the VPC, CNI, I think the load balancer. I don't remember off the top of my head which ones are native, but So what EKS Blueprint will do is, as soon as there is a native support of EKS add-ons that are managed by the service and not by Helm, they are going to be transitioned over to the native solution. But it's not something that you need to worry as of now, as this is an introduction demo. So what we want to do, so already actually have done. So here is Cloud9. I just have an environment here, and I have access to CLI here. I can just look at the S3 buckets that I have. So some S3 buckets, very simple, nothing fancy there. The reason why I did is just to showcase that I actually have access. I already have, because it takes 20 to 25 or 30 minutes to deploy the infrastructure as a code for EKS Blueprints running on Terraform. I already did before, and I'm just gonna show you the template and maybe do some changes and apply those changes in real time, so you get to see just how it works. So I'm using so if you go on the EKS Blueprints and you go inside the example subdirectory, you have multiple examples of things that can get you started. So I'm gonna be using the EKS cluster renew VPC, and that's what you can see here, EKS cluster renew VPC. So within that, I made few modifications just to add, also the team construct on it. So if you look at the Terraform, on the top, you're gonna see a lot of the provide description. The Kubernetes is actually using the the EKS Blueprint Kubernetes, but it's also using the provider as Helm. So a lot of the add-ons are going to be deployed by Helm. And there is other, specific variables and local variables that we need for this. This is just simple Terraform. The cool thing is where the modules start. So first it creates this doesn't deploy in order, of course, but there is a module for EKS Blueprint, which actually deploys the cluster itself, like we talked about it. There is the module for add-ons, and here it actually deploys all the add-ons. We're gonna look in a moment, spend maybe a couple of seconds each, but there is also the supporting resource. And this is important because here we are, when you look at here, we are not trying to reinvent the wheel with EKS Blueprints. As an example, in this template and this cluster that I've created, I wanted to create a new VPC where my EKS cluster would sit. I was actually not, the EKS Blueprint team didn't create a new module. So we're just using the open source Terraform AWS module that creates VPC. So we're just using that, using the VPC module, creating the VPC for us. And then of course, once the VPC is created, we are using on the EKS Blueprint, which then create the cluster itself. So you can see here that is after it creates the VPC, it consumes the the outputs like the VPC ID and the private subnets in order to create my EKS cluster. Here, what I'm doing is I'm creating a managed node group, and that managed node group will be 3 instances that are managed of type M5 large. You can choose what you want. What I've done so far, and I want to show you, I created an application team. So already an application team called Team Red with some labels that you can create. So what the application team will do, we'll create a namespace for me called Team Red, and we'll actually attach some quota. So, on this namespace, I can only have 1,000 milli CPUs, 4 gigabytes. The limits, actually, you can request up to 1,000 MCPUs, but the limit you can only consume 2,000, right? So this is just Kubernetes objects and the quotas you can attach to specific open spaces. Namespaces. What I want to do is I want to create another team. So I have this Team Blue created, and this Team Blue is just gonna call Team Blue. Project name, Project Blue. That's just the labels that are going to be associated to my namespace. Some quotas that are very similar, can only have maximum 20 pods, 20 secrets, 20 services. And the cool thing, it also allows you to deploy some manifests automatically to the team. So you see that this manifest in blue is the directory. If I navigate here, it's just a config map called game demo. So I want to show you how this works. So before, if we navigate into my Kubernetes, so if you do kubectl, let me make this a little bit bigger. Hang on 1 second. Kubectl get nodes. So if you just want to see the nodes that my kubectl have, you can see that those are the 3 nodes that you saw, M5 large nodes. But when you look now at the namespace, kubectl get namespaces, you can see that I have 18 red, but I don't have yet a Team Blue. So I added the Team Blue here, and the few other things I want to add is on the EKS Blueprints. You can see that I'm having VPC CNI, Core DNS, everything already enabled for us. But I want to enable KubeCost, which allows us to manage cost on EKS and Kubernetes clusters, and also enable Chaos Mesh. So I'm gonna save this. And then, of course, I'm going to run, my Terraform was already initiated, so I'm just going to run Terraform, apply, -- auto approve. And let's hope for the best that this works. So while this is actually going through, let's open a new terminal here. Let's just open a new terminal. And if you see kubectl get pods -a. If you see, I haven't deployed anything on this. Everything that is deployed on these Kubernetes are actually deployed from the Terraform EKS Blueprint. So you see that he deployed the CloudWatch metrics. And if I go on CloudWatch, it has already integrated with CloudWatch containers inside. All my metrics will be there. If I have time, probably not, I could show you. But it has Gatekeeper for my open policy control. It has cluster autoscaler, even though I have already three and a desired state of 3 nodes and a maximum of 3 is not going to do anything for this demo. But you can see that it has deployed the EBS CSI, and the metric server. Those things do not come as on the vanilla EKS cluster that you would create just by clicking buttons on or calling CLI commands. So let's just see how is this doing. So this is actually going and it's deploying. You can see that it's actually deploying the KubeCost module, but it has potentially already made it enable for me the new namespace of Team Blue. So if you go and you check the namespaces, you can see that Team Blue is here, which is amazing. And now, if you remember, Team Blue would actually deploy also a config map with it, right? So if you check get config map from namespace Team Blue, you can see that I have a game demo, right? So if I do kubectl describe config map -n Team Blue, you see that this config map, it's exactly, so you see color bad yellow, color.bad yellow, you can see the color.bad yellow. So it deployed automatically for me. And then, finally, it has deployed everything that I said. So it deployed the new team, and that is associated with an IAM, that team will only have access to the namespace, but it also deployed Chaos Mesh and KubeCost. So if you go and you check, so if you get the pods, kubepods-a, let's just do a grab for Chaos Mesh. It has actually deployed Chaos Mesh for me. And the last thing I'll show to you, because I'm running a little bit out of time and I do apologize. If you go here, just give me 1 second. I have this command, so let's just forward this port of Chaos Mesh. So what I'm doing is just forwarding to this machine that I'm using at this development environment, the Chaos dashboard, just to show you that this is actually running. So if I go preview application and I click here, you can see that it has redirected into my Kubernetes cluster Chaos Mesh. So this is just loading. I would potentially create the configuration for Chaos Mesh and it's up and running for me. So this is it for the demo. I know it's not very, super in depth. What I recommend you go into the Git repository and the workshop links that I provide before. Spend some time, contribute to the community. Feel free to reach out to me on my social media, especially on Twitter, @SamuelBaruffi. I'll be more than happy to have a conversation about anything related to cloud or technology, of course, including EKS Blueprints. Thank you, everyone. It was a pleasure, and enjoy the remaining of the DevOps India 2023 conference. Bye-bye.
Thank you, Samuel, for that insightful presentation on EKS Blueprints. So we covered a great number of topics in a short period of time. And now, on the behalf of the CNF community and everyone present here today, I'd like to thank you for your contribution to this event. And as our next speaker, we have Sangam Biradar, and he is the community leader of CloudNativeFolks. And now, without any further ado, I will turn it over to you, Sangam.
Hey, hello everyone. My name is Sangam, and today I'm going to present around multi-cloud security platform for discovering threats in production using ThreatMapper. So already you have seen one session around the EKS, how to use So this is more related to how to secure your whatever the cloud native infra or what you are provisioning, how to detect the threats in the real time, and we'll see the live demo end of the session. Um, so my name is Sangam. So I run a Docker community Bangalore and also a um, Docker community leader award winner, and I write a blogs. You can visit blog.cloudnativefolks and you can contribute also. Uh, so this is a little intro about me. You can reach out me on the social media if you want. Uh, so first of all, when you say the cloud, there are three parts which is very important. I think one of the thing is cloud security model is very important in the whatever you are using, software as a service or platform as a service or infrastructure as a service. So most of the software as a service is a consumer based platform that help you to build your applications to you can build your artifacts, and infrastructure as a code is you can build whole infrastructure uh, within some clicks, and you can provide that as a service. So as name itself you will understand what it's mean, and each and every phase the security is very important. uh, so next is w- what about the cloud security in the share responsibility model? When you everybody use on prime or their physical environment, uh, or they use actually they use uh, on-prem data center, or any public cloud or community cloud. So there are two parts very important. One is security of the cloud, which and security in the cloud. So whatever the security in the cloud part that we manage, we create EC2 instance, we create some resources. That is our responsibility. How we are configuring those services, how we are managing those things, and that is very important for any developer to take care, to have the best practices around it. uh, so there are two important part. Whatever the services you are consuming, how you are configuring it, maybe that is a customer data, that is identity, IAM roles, maybe that is your OS level security, maybe your network, what you are allowing uh, in the network security groups. So that is totally your responsibility. So this is very important for an engineer or the beginner, or any a cloud native developer, those who managing these workloads. And we need to understand the security, what is our responsibility as a when you use these cloud providers. So eventually you have seen the dramatic shift in the development of the application. So we came from the monolithic application, then we adopted these VMs, then we run a containers on the cloud on your or even local machines. So this is very become very important for all the developers to how we share the security or what is our responsibility to understand when you develop some applications, and what is meant by the cloud native app also. It's a very important discussion before understanding or finding the threads in your environment, right? So this is a diagram. We already seen like software as a service, or like infrastructure as a service or platform as a service. But when you see the CNCF landscape, there are many projects, a lot of people adopting those open source tools, adopting those services, and each and every phase there is some responsibility. And what platform is providing and what application owner responsibility. This is very important uh, for when we think about the security. The most of the this cloud native workloads run on VM infrastructure, on maybe on-prem, cloud. It has storage, it has networking, and we can audit those logs. And there is provisioning service plane, which is you use to provision, use something like Kubernetes or container or serverless or infrastructure as a code. You provision your infrastructure using some manifest or some CNCF ecosystem project. And there is top of that, there is a managed service. In the managed service, there is some of the Kubernetes runtime workloads that you run or you deploy, or you use those to deploy your day-to-day activities or day-to-day application. On top of that, you build application, you pack it, you deliver it. And there are some dev tools. Those dev tools are very important, uh, that make your life very easy, so you adopt those tools to deliver better performance or increase the productivity in the DevOps pipeline. And there is top of that, there is a data classification or the accountability of your data. And there is how you are, uh, like user access policies is very important. So there are, in the infrastructure layer, Kubernetes as a service, uh, CAS, which is container as a service, FAS, which is again the traditional way, which is like combine of, which is kind of a serverless model. uh, there is a no code platform also available today in the market. So you don't need to do that packaging, building, managing your services, those kind of services. uh, is something, is a platform provider, and the platform, which platform you are using. And it's very important to know is that secure or not, right? Every layer, if see, there is some security, uh, is very important. uh, so what is meant by this when you select the infra cloud, the cloud native apps, right? Is it web app but not a kind of a microservice, right? And there are managed service like Elastic Bin Stack, which is you just deploy web app, it's automatically take care of your everything microservice and other things. You don't need to push a lot of efforts. There is it like event driven? There are some of the services, there's like serverless technologies or services, so you need to see those kind of services also. Like, you whenever the traffic comes, the serverless application scale up. Does is there any Kubernetes orchestrator available, or is it portable for the multi cloud? Those maybe a Kubernetes service, or there are a lot of Kubernetes certified distros nowadays. But you need to ask these questions when you start developing your cloud native apps. So it's make sure that what service you need to use it, right? So it give you the more clarity on the, for the developer, which kind of method I can go for, or what is the benefit when I deploy, and also what is the benefit when I see point of view of the security. So introducing ThreatMapper. So ThreatMapper is a tool. It's open source. It's do following stuff like vulnerability scanning from the host, Kubernetes, SBOM. It's detect your cloud misconfiguration, road identity, service permissions. It's detect your secrets. Are you exposing any secrets tokens? Um, Also, it detect the malware. So we use something called Yara rules. Yara is a language for the forensic purpose. So it's detect all your workload. That may be a serverless, VMs, container, Fargate, AWS, Azure, GCP. So first of all, it give you a topology of view, what inside. If you can't see it, you can't secure it, right? And that is very important. So before seeing the demo and everything, we need to look how. this ThreatMapper actually work and how you can spin up this app or this service on your infrastructure or locally, right? So there is one part is management console application, which give you the user dashboard. So you can use for within your organization, or you can use uh, within a team. You can give access to your team to use this tool. So basically, it's you can spin up this thing using Kubernetes cluster. You can use using Docker Compose. You can use using kind of Fargate. You can use a Terraform. There are multiple ways. And when you deploy those things, now let's say you want to do a customized stuff. Like, once let's say my management console deployed, then I connected all the cloud which I want to see the topology or what my workload look like, or the thread graph. So first you do that, and after that you connect your component. And there are multiple feature I'm going to talk, but this is how it's work. Either you can like do as a Docker host, or you can go as a Kubernetes cluster, or you can spin up using Terraform. So there are multiple ways. So this is the short cheat sheet, you can say, how to deploy, or you can clone from your Docker Compose. Make sure your Docker install, then you can do a Docker Compose up. So it will spin up the management console for you. Then you connect other component to it. So there is another way you can do on the Kubernetes also. You can do. We use the OpenEBS. This is you can use the manual step by step, so you will get a console and everything deployed on Kubernetes. If you want to make like easy way, you can use a help chat. So within one single click, you get an installation of it. So that is okay. You have the Kubernetes, you have containers, you have the cloud, you have the on-prem, multiple thing, right? And you have the typical DevOps pipeline, which is developer code. So in every stage, if you see in this diagram, we are losing something if we don't do a secure code practices. And in each pipeline, we lose something, right? We The security or attacker, there is always a threat, right? And if you see the recent Log4j attacks, uh, so when you adopt any open source tool or any libraries, and we deploy blindly, you don't know what we are actually using. So basically in this, what is meant by a SBOM is software bill of material. We all go to the restaurant, right? We order something, we get a nice bill, we get a menu what we order, we know what we are eating and what we got on a bill. So same like for the software, uh, what we are actually using, that is very important. And is that enough secure? Those dependencies, those artifacts, those containers, those workloads, is that enough? That is enough secure or not? That is very very important uh, when you do or move your things into production. And that's why the security observability come into picture. um, and you need to start from the dev side, the developer side. You need to do some practice also ops side. So both side you need to like shift left shift right kind of approach you need to adopt. And you need to monitor every side before the production, after production. So make sure that the attacker will not take any benefit from it. So this is typical it's look like the typical management console. You have the different you see the vulnerability based on your language, what your resources using. And I'm going to show more around it. You can download your SBOM, you can see SBOM report. Um, so there is another open source project which used in ThreatMapper and in Secret Scanner, which allow you to scan your whatever the exposed secret. It will give a detail around your images, Docker images, and the file system. So if you want to use Yara Hunter, which is typically a malware scanner which use Yara rules, So you pull first image and then you run using the following script, and in that particular image, if there is any malware or vulnerabilities threat, it will detect, it will show the report around it. So this is very unique feature. Another thing for the security is very important when we use the cloud and everything, the network part, the networking. What component in the Microservice architecture or what component is talking to which, how traffic is flowing, and we do that using the BP, eBPF technology. And eBPF technology is actually hooking into the kernel level, and then we actually take all the packets whatever um, you were like whatever the pcap packet file you take, and it will show you all the detail around what happening in your network, so you can detect better kind of security. So one of a example here, let's say there are three surveys, we deployed the sensor on that. That may be a WordPress, that may be a Nginx, right? And that hosted on some servers like Kubernetes, Docker, Fargate, or host. So we capture all the data, we receive all that PCAP data, and then we analyze those things. So this tool allow you to analyze what happening, how attacker can attack, and this is very important in perspective of observability and monitoring. So for the demo, so we have the community site community.defense.io. So I'm going to show the demo. If you want to see same demo, use this link and username and password, and I'm going to show you live walk through how it's work and all. So let me bring the demo for you guys. Hope it's visible. Now you need to go to the community.defense.io, then you go to the doc, and then you go to the quick demo. We created a read-only demo for you guys. You copy this URL and username and password. Uh, you can use browser. So this is just give you the overview how it's look like. Once you log in, if you see in this my environment, I see some of the workloads that is already deployed. So I see AWS. When I see whole the topology of my whole environment, whatever the cloud, maybe you can use multi-cloud, right? As the topic is multi-cloud. So I can drag and drop. If I click that this AWS stuff, so basically we are scanning whole the infrastructure. So I see that there is a Kubernetes cluster. If I click the cluster, um, it's basically showing me the pods, right? The Kubernetes resources. And it also showing how much CPU and everything using. I can scan this particular stuff using the scan button. And now I can here configure what kind of application I want to scan. What maybe you're using Golang app, whatever the backends and everything, you just prioritize it, your scan, and you can click a scan button, right? This is one of the feature that it's give you the topology as name of our company say like deep fence. So we give a deep observability. uh, Also with the security we map the vulnerabilities, and you can go actually inside each and every component, whatever the inside, you can look and you can see what happening actually you can check a labels, you can check a metadata and everything. So this is one of a thing that ThreatMapper provide. Another thing is, let's say you are a CISO or the security guy, and you have the infrastructure, you use different resource, cloud resources. So we get this nice threat graph, which give you how many threats are available in the environment, so you can easily detect and remediate your whatever the vulnerabilities you found. And if I see whatever the vulnerabilities I got uh, in my environment, so I can you can select the time, you can see the S bomb, a report. So basically you can check the secrets. Let's say I use different environments, and now you might be exposing some of the secret accidentally, and there is no tool in the market that give this kind of it detects all the your cloud, and it's managed by you, not managed by us. So it's this particular console is managed by you, so we don't collect anything. So you are managing this particular management console. We actually support all the cloud provider. Also, we support cloud formation and Terraform. And also, if you see, you can see your all the accounts details. Once you connect, you can see all the result. We support all the compliances, major compliances. uh, so you can start a scan. You can see the scan result. See, if you see, there is one account which is connected, which is Google Cloud. I can start a scan. I can check particular compliances which I want, and I see particular vulnerabilities in my environment. I will just say start scan. So you just need to start a scan. You will get a result here. It will take a little time to scan all the your Docker image, everything. You can connect your registries as well, and you can integrate your to Slack, your ticketing platform, or you can automate whole things. And if you go to the setting, you get direct script. You can just copy and run this particular script on particular environment. So those cluster, this agent actually connect to that those components, and it will show you the. And we support most of the container runtimes. You can uh, use helm chat also. So you can use particular integration. It's useful for the teams and everyone. So if you want to know more around this tool, go to the GitHub, and you'll get all the resources here, and easy to use. If you need any help, um, always reach out to the defense community. And that's my demo. If you have any questions, please make sure comment. Make sure join the Discord uh, community, uh, and also make sure if you have a question, and share this video, share this live stream with in your network, so other people can take a benefit of these sessions.
And that was Sangam Biradar sharing his expertise on MultiCloud Security Platform. It was a truly enlightening session, Sangam. Thank you so much. Thank you so much for your time and sharing your valuable insights with us. I hope you all found it as informative and engaging as I did. Next, we have Nicolas Frankel, who will throw light on open telemetry tracing. So, Nicolas is a developer advocate with 15 plus years of experience in consulting for many different customers in a wide range of contexts, such as telecoms, banking, insurance, and large retail and public sector. Usually, he's working on Java and Spring based technologies, but with focused interests like CI CD, DevOps, and testing related to DevOps. So he also doubles as a trainer and triples as a book author. So now I'll turn it over to you, Nicholas.
here for this talk about an introduction to OpenTelemetry tracing. I'm Nicolas Frankel. I've been a developer or an architect or whatever for a long time, like more than 20 years nowadays. And since a couple of years, I'm also a developer advocate. So given my history, I can tell you about what happened a long time ago, like perhaps even before some of you knew about IT. So in the good old days, or not so good, we had monitoring. And monitoring meant that you had a bunch of people like sitting in front of a huge screen full of like widgets, with dashboards, with graphs, with whatever. Sometimes they even had an additional screen in front of them, and they were actually monitoring, like visually monitoring the situation. Sometimes you had even alerting, or alerting came afterwards, but basically monitoring meant you had like low-level information into your information system, and you had to have people who could like realize that, hey, this like slight anomaly here and this slight anomaly here meant that actually something bad was happening. It was working more or less, but actually system became more distributed. You can do this kind of stuff on a huge monolith, but when you have components starting to interact across the network with different machines, with different nodes, then having this kind of like insight into the system through experience becomes very, very hard. And so monitoring gave way to something called observability. So you can think about observability at the next level as to provide insight into not only one single component, but about distributed system. And there actually are three main pillars of observability. The first is a metric, the second is logging, and the third is tracing. And though I will focus this talk on tracing, I still need to introduce the others two because they make a lot of sense and probably you need to be aware of them anyway. So as I mentioned, the first step to monitoring was to have metrics, and it was easy because nearly all operating systems give some way to release the data of how they operate. So you can have the CPU usage, the memory, the swap memory, the number of threads, or whatever. And this is very easy to get, but as I mentioned, if your system becomes more complex and involves more machines, it's not possible to have them. So nowadays, we still rely on those metrics, but we want to have higher level metrics. They can be like still technical metrics, such as the number of requests per second, or the HTTP status code, or it can be like business metrics, such as the number of orders and this kind of stuff. Now comes logging. Logging is another level of complexity. Logging, there are different questions you need to solve. The first question is what to log. For example, in the past, it happened that I used like a Java agent to log whenever I entered a method and whenever I exited a method. So when I read the log files, I could see like which steps were used. So I could do some kind of debugging in production just by looking at the log. This is good. This gives me some insight. Actually, it's more like tracing, but it doesn't tell much about how the business side of things. So again, perhaps we want to log more interesting stuff, such as who is connected, what's their session ID, how much items do they have in their code, this kind of stuff. This is much harder and it requires manual intervention. So you need to have a requirement and the developer like actually writing the code to log this. Of course, with auto instrumentation, you cannot log every parameter of a method by default because some of them might be a password and you don't want to log the password. So auto instrumentation in this case of logging is easy but doesn't provide much value and can be actually harmful to the operation. Then the logging formats. For a long time we use whatever logging formats the framework provided us, whether you are using SLF4j, Log4j, Log4j2, whatever. But nowadays it's perhaps better to use directly JSON so that when you send it to another system which expects JSON format, you don't need to have an intermediate operation that actually transforms the human readable log into JSON format. Like directly print it in JSON format and you avoid one additional potentially expensive operation. Then where to log is also important. When I started coding, I was explicitly forbidden to write to console. Like if you use like Sonar or any other quality tool, they will tell you, hey, it's forbidden to use system.out.println or system.err.println. You don't write console. Nowadays, however, with containers, you probably will want to write to the console so that it can be scraped and again, like, sent further. Logging on a system is good when you've got a single component or perhaps two components. As soon as you've got a distributed system, you need to aggregate the logs together so as to understand again what happens across all those components. Therefore, you need to get all the logs from all the components into a single place, into a centralized logging system. And again, that's more question. Basically, you need to ask yourself, should I send the logs? And basically meaning that my application will lose some performance to send it and actually might crash the app? Or do I expose only the logs so that another component can scrape them? This is how Prometheus works. For example, you add some endpoint and Prometheus will scrap the metrics. Loki will do the same. I mentioned about parsing the logs. Again, it's better to actually write them in a format that the centralized logging system can directly exploit than to have an additional operation in the middle. Then you need to store the log, of course. Then you need to somehow search for the log because, well, just having the logs one by one is not interesting. So you need to search for them according to some filters, for example, a timestamp, for example, a transaction ID or anything. And then you need to display them in a certain way to look for the interesting bits. For example, the components that produce them. And I didn't write it, but of course you need to somehow afterwards get rid of the logs. Otherwise, your logging system will grow and grow and grow, and well, you probably will have your disk full in no time. You probably used one of those systems. In the past, I've been using Elasticsearch a lot. It's quite useful, but any other system will do. Then comes the third component, which is tracing. The Wikipedia definition, I love Wikipedia definition. In my opinion, this one is not a great one. So I've come up with my own. You will excuse me, probably it's not my own. I've got inspired by lots of people that I don't remember, but well, credits to them. So basically, tracing is a set of techniques and tools that help follow a business request. across the network through multiple components. This is really, really important. Again, in distributed system, you've got multiple components. Your transaction, your business transaction will require all of those components to work together to achieve the business goal. If one of them fails, you're in deep trouble. And if it's repeatedly the same component that has an issue, you need to be aware of it. So tracing the request across all those components is important. I believe you probably are aware about some of the tracing pioneers existing already. So there is Zipkin, Jaeger, OpenTracing. Those are the three most widespread and famous. Every one of them had proprietary interfaces and implementation. But as you know, we want something to be standardized so that the whole software that you write, we can write libraries that have one standard. And for that, there is something called the W3C trace context configuration. It's quite easy to read, so you can already do that at home. And basically, if you don't have time, let me refresh it for you. Basically, you've got two important concepts. The first concept is the idea of a trace. And trace is actually like the abstraction of the business transaction. So the trace will go from the entry point to the utmost deeply nested component and back again. That's the trace. And then you've got a span. The span is actually the execution of one part of the trace in a single component. And you can have, of course, for each component, you can have multiple spans if you're interested, where inside this component, where the flow of the request goes. And each of those spans are bounded together in a parent-child relationship. So the first one is the important one, the first component is the important one. It gives the first span ID, and then the next component will check the span ID of the parent and will say, hey, I am this span ID, so it also generates a new span ID and say, hey, I'm bound with this one. And through all those parent-child relationship, you can actually make sense of the flow and check the flow overview in one set. OpenTelemetry is a set of tools that implements observability and that relies actually on W3C trace context. So it's an implementation and more. So it's compatible, and it also go beyond, because W3C is good for web stuff, but perhaps you want to trace a request through, I don't know, Kafka. So somewhere where you can store, and in this case, the specification doesn't handle it. OpenTelemetry allows you to trace these business transactions across many different components, not only web ones. If it's a merge of the OpenTracing and OpenCensus projects, so it's one of those few merges that were successful, where people decided to join their efforts to create something better. It has become a CNCF project, which is good, meaning that it has support. It will be supported for a long time. It's licensed under the Apache license, so it's also good if you want to use it right away. You don't need to acquire a license or whatever. And it's hugely popular, especially on GitHub. The architecture in itself is quite easy. Basically, you've got components, whatever they are, and then you've got what they call an OpenTelemetry connector. And this OpenTelemetry connector accepts data in a specific format. And this specific format allows to have this like parent-child relationship between spans. So the idea is on the client side, you've got stuff that dumps data into the hotel collector, and then you've got something that is able to search and display data from the hotel collector. The OpenTelemetry collector in itself doesn't provide anything. It's just a storage stuff in a certain format. So we need something afterwards. OpenTelemetry provides a dedicated collector, but actually Jaeger and Zipkin, which are also like tracing providers, they are able to provide the same collector, or let's put it that way, they also provide a collector which accepts OpenTelemetry data. So basically what they did, they kept the storage engine, they added a new interface where you can state your data in OpenTelemetry format. If you already have your architecture, your tracing architecture, you can easily move to OpenTelemetry because, well, the collectors of Zipkin and Jaeger, they have this additional interface. You just need to change the formats and the ports, because I think every one of them has different ports. On the client side, it's, well, I wouldn't say easy, but the first step is straightforward. First step is auto-instrumentation. This is only available when you've got a runtime. For example, on the Java side, you have the GVM that is on runtime. On the Python side, well, Python is a runtime. Node.js is a runtime. In this case, you will delegate to the runtime to do like auto-instrumentation. I told you about like automatically logging, entering and exiting a method. It's exactly the same. Here, you will do that automatically. It gives you already a lot of insight. Now, if you want to go further, you can actually get the library depending on your tech stack. Again, you can check the OpenTelemetry website. You will notice there are lots and lots of stacks that are supported out of the box. And for Java, there is one. For Python, there is one. For Rust, there is one. Whatever rocks your boat, probably you will find there. And then you can either like call an API or use some annotation. As I mentioned, auto-instrumentation, very easy to do. You don't need to couple your application to OpenTelemetry. It's a low-hanging fruit, so you should probably do it right away. If you are using a distributed system, it will give you a lot of insight into your application. I mentioned it's practical introduction, so here let's try to do some practical stuff finally that we have delved into the theory. So here is my use case. My use case is, well, simple for a real application, but a bit more involved for a demo. So at the beginning, I have an API gateway. I'm using the Apache API 6 gateway. It forwards the request to my main application, which is a Spring Boot Kotlin application. Actually, it gives like products API, and then it has the detail for the product itself, but it relies on two other components. The one for the pricing is implemented in Python through a Flask framework application, and for the stocks, so how many items do I have in which warehouse, I have created a Rust application using the XM framework. So the entry point is actually the reverse proxy API gateway. Most information systems have such an entry point. You probably never expose your application directly over the internet. You have something in between because, well, you are like, you want to protect your information system from illegal access. So that's the most important part. As I mentioned, I'm using Apache API 6. Perhaps you don't know about Apache API 6. It's an Apache project, so basically, again, like good for maintenance. Everything will be there with a license that will never change. It's based on the very successful Nginx reverse proxy. Then you've got like a Lua JIT additional open REST layer on top, which allow you to do scripting in Lua over the Nginx. And then you've got out-of-the-box plugins. So to configure it, there is this general configuration. As I mentioned, they're like Apache API 6 as a plugin architecture. So here I say, hey, I will be using OpenTelemetry. It's an out-of-the-box plugin. You don't need to write any code. And then you can tell, hey, this is the name by which I want to be known in the data of OpenTelemetry, and this is where I will send the data. So I will be using Docker Compose, and so I have a dedicated Jaeger component. Then for each route, so here I have a single one, but you can have different configuration depending on which route, you will say, okay, how much sample do I want? Normally, and depending on your volume, you probably don't want 100% because it will overflow your stuff. You want a sample. Here, this is a demo. I will say I want to sample everything. Again, probably not what you want to do. And then you can log additional attributes. So here, for example, I decided for no reason, but for demo purpose, to have the root ID, the request method, and an additional header. So if I can pass through the client some headers, and they will be like traced along the span. The next step is the JVM level. As I mentioned, JVM is a runtime, so I can easily use auto instrumentation. And on the JVM, auto instrumentation is through a Java agent. So this is quite easy actually. I just need to pass the Java agent when I start the application, and I don't need to write anything. So your developers, they are completely isolated from this tracing concern. They can write their code and everything will work as expected. This is regardless of the language and the framework because it's JVM. So here, this is how it works. Here is my Docker file to build my Docker container. This is a multi-stage Docker file. First, I will compile everything through a JDK, and afterwards I will run it through a GRE because I don't need a JDK and it's actually bigger and less secure. So the first thing I do is like normal standard build, and then afterwards I get the jar that I just built and I add the Java agent through GitHub. And when I run it, actually I run it through the Java agent. And this is as simple as it gets. You cannot be simpler. Afterwards, you can do more precise, more fine-grained calls through manual instrumentation. It needs an explicit dependency in the application. This time, your developers need to be aware of it. And then there are two ways to do that, either through a regular explicit API call or through annotation. I'm benefiting from Spring Boot, so basically I will use annotation. I will issue the code just afterwards. Okay, now it's time to delve into the codes. I will just focus on the Kotlin Spring Boot ports. Everything is on GitHub, so in case you need to check, you can check the Python part, you can check the Rust ports. Here I will focus on the Java stuff. I've created my application on Spring Boot Starter, start.spring.io. So here I'm using the latest version of Spring Boot. I'm using the latest LTS version of Java, which is required by the latest version of Spring Boot. I'm using also the latest version of Kotlin. And then it's a reactive application. So I will be fetching data using R2DBC. Otherwise, I'm using Webflux. So again, to be reactive. And the rest is just like standard Kotlin stuff. I didn't want to bother myself with a regular database, so I'm using H2, using the R2DBC H2 reactive driver. On the code side itself, here I'm using Kotlin, so I want to use coroutines because, well, that's how you can do easily reactive code stuff. So I'm using the coroutine CRUD repository. This is my R2DBC repository. Here I have a handler. And you can see that I have suspend function. Suspend function are like for coroutines in Kotlin. Then I have one endpoint and the other endpoint. This one endpoint is for all products. This one endpoint is for a single product. Let's see the first one, okay? And then the rest will be exactly the same. So I will fetch all product. I will find all of them into the repository, which in turn will look into the H2 database. And for every one of them, which probably what you shouldn't do in real life, I will fetch the product details. So whether, not whether, but their price and their availability in the stock. So here I can see how it works. Again, I will have two different calls, like protected under an async block, which means that here, because I'm using dispatcher.io, they will make the calls in parallel. And we can check that it works like this in the traces. So I will get the price, I will get the stocks. Then I will merge everything. And here is how I merge everything. So I transform data into the expected data. And at the end, I create a product with details, including the products from the database in the catalog, plus the price, plus the stocks that I have changed a bit. For example, I don't want to return to the client any warehouse where the quantity is 0 or less, because, well, not 0 or less, just 0. Doesn't make sense, so I just filter them out. And at the end, I'm using the beans DSL from Kotlin and the router DSL, or here the co-router DSL, to assemble everything. And I start my application with this beans method. So even if you are not familiar with Kotlin, if you are a Java developer, I think it should talk to you. And here you can see my two endpoints, /products for products and /products /ID for my product. Now I assemble everything through Docker Compose. So this is the Docker Compose file. I'm using Jaeger. Jaeger is available in multiple flavors. You can have different containers. For example, here I'm using the all-in-one. So I'm using the batteries included package, Docker image in this case. So I can already have the OpenTelemetry collector provided by Jaeger. So it's not the OpenTelemetry collector, it's the Jaeger collector that allows an OpenTelemetry interface. So here I don't need to think about the architecture of Jaeger. I'm just using the Docker image that does everything. Then I'm using API 6 because I want to protect my services. Then I have the catalog, which is the Spring Boot Kotlin application that I've just shown. And here I need to tell several configuration parameters. The first one is, where does the Java agent need to send the data? Well, to Jaeger on this port. How will it flag this component? Here it will be called orders, which is wrong, it should be catalog. Then here, does I want to export metrics? Here I said no, I don't want. Of course, depending what you want to do, you can also export metrics and logs the same. And now pricing, I do the same for the Python application, but again, this is not relevant for this talk. So here, pricing, same stuff for the Python application, not relevant for this talk. Stock, same thing for the Rust application, not relevant for this talk. Let's start this architecture. So it might take a bit of time, especially with the JVM to start. I will just like speed the time and let's go very fast. Okay, the logs tell us that it has started. We can check with Docker PS. Docker PS. So here it seems that everything has started. We've got the catalog, the pricing, the stock, and Jaeger. Now we can issue our first curl. So curl, I will be using the header that I have configured Apache API 6.4. So if I remember, it's hotel key. And then I can say, let's say hello world, because I have no imagination. And I'm on localhost 9080, which is Apache API 6 default port, and we'll say products. So it takes a bit of time because it will go through all our systems. So here you can already see that the catalog has taken, then none of the stocks, the pricing, and Apache API 6 as well. So we've got the response, which is not very interesting as it is, but it still gives you the data you ask. And now the idea is to check the traces. So I'm now on the Jaeger web UI, and I can check, and I will go exactly here, and here we can see all the services. So there are some traces. Here I need to refresh because here I need to find the traces. And here we have a single request because we sampled everything. Here we have it, and we can see already with only auto instrumentation a lot of interesting data. So we can see that we have our API 6, which is the entry point. And here we have the orders, which I misnamed. It should be called catalog, but here it's orders. And here we have the product. Here we have the first auto instrumentation inside of product because we are using Spring Boot. We have lots of proxies inside, you know how Spring Boot works. And here I decided, hey, here I will make a call for a proxy. I will trace it. Here we have the find all. Why? Because it's an interface provided by Spring Boot. We didn't provide the implementation. So basically, again, it's a proxy. So it's automatically traced. We can see here that there is a call to the other components called stock. So it's traced as well, which is good. And here we've got the second one. So here there is one for stock and one for pricing. And here we see that in one case, I went directly to the component and the other one went through the API gateway. Both are completely possible. This is how I configured it inside my architecture. Basically, in one case, you can say, I want to protect everything that I always need to get back to the API gateway to do some authentication, authorization, whatever you want. And the other side, you say, oh, I'm pretty secure. I can directly go through it. But it gives you insight into your architecture as well. In case you misconfigure something, you can check it through the traces. Something interesting as well, we can see that the get calls through to the stock and the pricing, they are made in parallel because we use coroutine. So this is also a good way to check that you actually coded your stuff correctly. If you see one going after the other, then probably your code was not right. Though tracing is not made to do that, you can also validate some of the code. And then, as I mentioned, it's not good to do that, but here, for each of them, I go to the stock and the pricing, stock and pricing, stock and pricing. And we can check, for example, that on Apache API 6, I actually have the additional stuff that I sent. So basically the routes and the get. And here I'm missing the hotel stuff, so probably I didn't use the right one, but believe me, it should work. Now that already gives us some information about our flow, but we might want to better. We might want, for example, on the get to say like which internal method did we call which parameter. So let's do it. So now I want manual instrumentation. It means I need to explicitly couple myself to the library. So here, because I'm using Spring, as I said, I want annotations. I don't want to have API calls. Actually, if you check the documentation of the OpenTelemetry in Java, to get an exporter is not that fun, requires a lot of API calls. And well, I have annotations. Spring Boot is compatible with OpenTelemetry, so let's use it. So I've added this like additional dependency in my code. And now we can check the application itself, the code itself. And we can go here. And here we can see that I've added like here this with span. So this with span means that it will be instrumented and you will find it in the trace. So I should have this product handler products. If I'm calling one single product, I will have this one. But it's also possible to use additional details. So for example, here I will have this product handler fetch, but I also say, hey, here, not only capture this call, capture this ID. So which product ID will I fetch? Which means that here it's interesting because normally I shouldn't need it. Here you see that the ID parameter is not used because I already have the product. But because I want to capture the ID, I need to separate this parameter. So I wouldn't be able to capture the span attribute product because then I would have not the ID, but the whole memory reference unless I create a toString, whatever, which is not a great idea. So here I change my method signature a bit to explicitly pass the ID, and then, well, I don't use it. But then it means that this will be captured by the tracing, by Spring Boot, and I will find it, which might be super useful, especially if it fails. So normally now everything should have started, and we can try again with this configuration. So here it's the same request. I've just changed the header because I missed the previous header. It was not hotel, it was OT. So let's run this. Again, we can check that everything works on the logging side. So here I'm in the catalog, then I'm in the stock, the pricing, whatever. I've got the response, and we can check back on the Jaeger UI how it looks like. We expect more details. So first, we can already see that we have more spans than before. Just to check on the Apache API 6 side, we can see that now my OT key, this header, has been logged, which is good. And then we can see that I have the products here. I have the fetch here. So basically, we added additional data. So inside the components, we added a couple more spans to understand how the flow of the code went inside the components, not only throughout across components. You can also see that I did the same in Python. So if you are interested, you can check the code. So here I'm logging the query, like manually, unfortunately, but I'm logging the query so you can have additional information what you are doing. So thanks for your attention. I hope you learned something. I showed you how you could use OpenTelemetry, how you could use auto instrumentation, how you could use manual instrumentation, and I believe now you can start your journey. You can follow me on Twitter. You can follow me on Mastodon if you're on Mastodon. I previously wrote a blog post about OpenTelemetry. It's much more narrowed focused. I've improved the demo code a lot, but perhaps you can read the blog post. It might give you some insights. If you're interested about everything, so the Python, the raw stuff, everything is on GitHub. I will be very happy if you check it and if you store it. Just to check, there is a bit.ly URL. So basically, I can see how many people were interested in the code. And though the talk was not about Apache API 6, if I got you interested in Apache API 6, then you're welcome to greet us and have a look. So thanks again for your attention, and I wish you a great end of the day.
Thank you, Nicolas, for that insightful presentation on OpenTelemetry tracing. Your expertise and knowledge have been truly inspiring, and I know the audience has learned a lot from you today. On behalf of the CNF community and everyone here today, I'd like to thank you for your contribution to this event. With this, we'll move further to our next topic, DevOps coupled with testing, security, and automation. And we have Siddhant Wadhwani as a speaker for it. Let me brief you a little about Siddhant. So, Siddhant is a versatile self directed leader with over 7 years of professional work experience in the IT industry. And currently, he's working as a project lead SDET manager at Newfold Digital, managing SDETs across several teams within Asia Pacific engineering, while mainly focusing on test execution and automation excellence. He has played a key role in forming the basis of test management and automation best practices within a couple of projects and is working closely with his team now to extend those learnings across the organization. Right from design discussions to architecture reviews, shift left testing to in sprint automation, adhering to code review guidelines, and having a focus on non functional areas of testing, Siddhant simply leads the way to set the best quality standards. Siddhant has been recognized as a browser stack champion and is an active speaker at various conferences and events, mostly in association with Browser Stack and the Test Tribe community. Of late, he delivered an in person keynote talk at WordCamp Kolkata 2022. And above all, in his spare time, Siddhant loves to attend tech conferences and network with like minded individuals. He's very fond of playing badminton, table tennis, and leading, listening to One Direction as well as traveling as his hobby. So, the best way to reach out to him would be his LinkedIn or his personal website. And yeah, over to you, Siddhant. Now you can begin with.
Hey, thanks Shreya for the quick introduction. Also, great insights from Samuel with his tech demo on EKS, Sangam talking about multi-cloud security, and just hearing from Nicholas about open telemetry and observability. Hello, everyone. Good morning, good afternoon, good evening. Thank you so much for joining. Indeed, it gives me immense pleasure that we can connect today virtually from across different locations and time zones. Although I'm sure if we had met in person, it would have been a completely different vibe altogether. Nevertheless, welcome to my presentation on DevOps coupled with testing, security, and automation as part of DevOps India 2023 by the Cloud Native Folks community. As introduced by Shreya, my name is Siddhant Wadhwani, and I'm excited to be here today to share with you some insights on what DevOps is, why it has become an essential practice for organizations looking to improve their software development and delivery process. My main motive today would be to bring testing, security, and automation into the limelight while we discuss the best possible strategies and most efficient ways to implement DevOps across organizations. Talking a bit more about myself, I will be soon traveling to Bangkok to attend the WordCamp Asia event and network with WordPress web professionals from across the globe. So if you happen to be there, I'll be happy to meet you in person. And yeah, that's about me. If you wish to know more, feel free to visit my website, that's siddhantwadhwani.com, or you can feel free to simply Google my name. By the way, don't forget to follow me via my social media handles that I've put across. I'm very active on LinkedIn with about 9,000 followers. So, without further ado, let me take you over to today's agenda. Yeah, so as part of today's agenda, I'll first be introducing you to DevOps and talking about certain principles and best practices that organizations should adapt to deliver faster, efficiently, and with optimum quality. Second, we learn about the importance of testing in DevOps and why it's a critical component of the workflow and how does it fit in. Third, we look at security as another essential aspect that must be considered in a DevOps environment. Next, we'll deep dive into automation as a key principle of DevOps and understand the industry recommended strategies to implement DevOps better. Then, to ensure testing, security, and automation fits perfectly into the DevOps cycle, I'll be highlighting certain best practices that I've curated over time. Additionally, I'll be showcasing some real world examples while talking about the next steps for implementing the end to end DevOps approach. Finally, I'll end the session leaving you all with some key takeaways and open the platform for Q&A. All right. So, talking about software, we all know that software development begins with an idea, which is then transformed into a concept and eventually into a functioning product. To ensure the quality of the software, it is important to test it throughout the development process. Testing an idea is something that some people completely miss. Testing the idea is vital, investigating to uncover information, refactoring the idea to enhance and solidify it. This can be done through various methods such as unit testing, integration testing, acceptance testing, and more. It allows us to stem lots of different artifacts and we can test those artifacts to refactor the tool. And then we can use those artifacts to stem all the activities that we can conduct, from designing to planning to development, testing, and maintenance. It is also important to have a clear and thorough understanding of the requirements and to actively involve users in the testing process to ensure that the software meets the basic needs of the customer. Additionally, it is essential to have a robust quality assurance process in place, which should include code reviews, testing plans, and incident management. After all, quality software for one. With the advent of digital transformation, many organizations have been pushed to move faster and stay competitive, thus transitioning into an agile developmental model. Companies are embracing DevOps to help reach these goals. DevOps is basically a process that seeks to reduce barriers between development and IT operations, these both teams, in order to facilitate communication and collaboration. It is a solution to implement Agile, which has been around for quite some time now. It encourages the smooth flow of code from development to production by automating the redundant task, helping organizations stay agile and focused on the most important task. This, in a way, has elevated the quality benchmarks across, from shift left testing to sprint automation, continuous testing, CI CD, and DevOps. Things have changed for the better, allowing frequent and quality rich releases. The goal of DevOps is basically to improve the speed, quality, and reliability of software delivery and to make the software development process more efficient and effective. DevOps is not a tool or a product, it's a mindset and a culture and a set of practices which is here to stay and likely to continue being an important tool for organizations in this digital era. So let's talk about the principles of DevOps. First, we have encourage collaboration and communication. The combination of developers and operations being at the core of DevOps as a concept means that collaboration is the key, and this trickles down to other areas too. Second, always improve. This collaboration harvests an environment for continuous improvement, and this improvement is made easier by other functions of DevOps, such as automation. And that's where we move on to CI/CD and automation. Almost everything in the DevOps cycle, or you can say the life cycle, should be automated if not already. This includes communication between teams, responding to feedback from customers, updating new systems, as well as provisioning the infrastructure. This means maximum efficiency. Open source code is a big part of this. Fourth, and the most important, I would say, customer comes first. Isn't it a fundamental for any work? Well, that's how you make the money. One of the best ways to make the customer feel appreciated is to encourage feedback. DevOps encourages customer interaction, and this often has great results. Fifth, failure is a good thing. DevOps culture encourages failure. If you learn from every mistake you make, you're going to learn a lot more than you would if you simply edited and moved on. Teamwork makes dream work. DevOps looks for strong teamwork between individual members of each team. That's because everybody involved is required to be involved in most stages, if not all, of the project lifecycle. Last but not the least, end-to-end responsibility is the way forward. This means that everyone involved in the project is involved with every stage, at least to the point that they are aware of what's going on. This also helps to be more aware of the project's direction. Now, in order to achieve these principles, it is important that organizations should adopt a certain set of practices and tools to implement this in a more efficient manner and to deliver software faster. So, these practices would mostly circle around version control, where you have Git to manage source code and track the changes better. Then you have CI/CD, which is continuous integration and continuous delivery. You have tools like Jenkins, Travis CI, Circle CI, Bamboo to automate the software delivery process. Then you have infrastructure as a code. We'll be talking about it later, but there are examples like Ansible, Chef, and Puppet to automate the infrastructure provisioning and management. And lastly, we also have containerization like Docker and Kubernetes that help you to package and deploy software or manage containers. So, talking about the importance of testing in DevOps. Testing is basically a critical component of the DevOps workflow, and it plays a vital role in ensuring the quality and reliability of the software that is being delivered. In a DevOps environment, testing is integrated into the software development and delivery process, and it is performed at every stage of the process, as you can see in the figure. One of the key principles of DevOps is CI/CD. This means that code is integrated and tested frequently, and that software is released to production as soon as it's ready. Testing is the essential part of this process, and it's used to ensure that the code that is being integrated is of highest quality and that doesn't break any existing functionality. Automation is another key principle of DevOps, and it's used to automate as much of the software delivery process as possible, including testing. Automated testing allows organizations to run tests quickly and consistently and reduces the risk of human error. Moreover, automated tests can be run on a regular basis, such as with every code commit, to ensure that the code is always in a releasable state. And that's where we have the end-to-end CI/CD flows. In addition to integration and unit testing, testing in DevOps also includes functional and non-functional areas such as performance, security, and usability testing. This ensures that the software meets the requirements of the customer and that it's fit for purpose. Testing is also an important part of the feedback loop in DevOps. By measuring the performance of the software delivery process and using the feedback to improve it, organizations can ensure that the software they are delivering is of the highest quality. So, when we talk about how does testing fit into the overall DevOps workflow, well, that's where DevTestOps comes in, where the key focus is on continuous testing. Unlike the Agile Manifesto, Even DevTestOps has its own manifesto that was coined in 2018. As per the DevTestOps manifesto 2018, the goal of DevTestOps is not to silo test from dev and ops, but simply to raise the visibility of testers and testing as an integral part of the DevOps quality culture. It has set a culture where software developers, testers, and operation engineers work together, which adds value to the product, enhances quality, and helps in faster delivery. Moreover, DevTestOps ensures continuous feedback about application issues from testers to developers throughout the stages of the software development lifecycle. This reduces the business risk and the possibility of finding defects at early stages. It requires organizations to embrace all types of testing, not just test automation. This includes exploratory testing, test development, and manual testing. Testing the things that matter strictly to the product and the customer should be your company's top priority, which is why DevTestOps is such a critical role in today's organizations. Now you can see testing often has ended up being rushed for companies who have tight deadlines to get the final product released. More companies are now adopting the shift left approach, like Sangam mentioned earlier, which in theory means moving testing up earlier in the SDLC process. Testers' involvement right from the outset at requirements gathering stage eliminates the issues that crop up when testing is executed too late. The end goal, of course, is to provide continuous feedback to developers about the state of their code. This can also highlight any problems earlier in the process as well as reduce the risk that we would face later. So, talking about certain guidelines or 5 principles that DevTestOps follows, they basically circle around continuous testing over testing at the end, embracing all the testing activities over only automated functional testing, testing what gives value over testing everything, testing across the team over testing in siloed environments, and product coverage focus over code coverage. Next, moving about talking about security considerations in DevOps. As we are talking about DevOps, which provides a collaborative approach to development, security also becomes the primary responsibility for every team member. Thus, DevSecOps is a combination of development, security, and operations, which introduces some security tools to make the process automated. DevSecOps helps in primarily providing complete security for your application as well as the infrastructure from the initial stage of development. It has inbuilt security features that make it more reliable and robust. It fills the potential gaps and makes an application leak proof by regular monitoring and risk assessment. As you can see, each and every phase of the DevOps lifecycle, you perform various forms of security testing. Now, to address these security risks, organizations also need to adopt certain security practices that would be tightly integrated into the DevOps workflow. Those practices mostly circle around secure coding practices, like ensuring that the code is written securely and that it's free from any sort of vulnerabilities. Security testing, that means testing software for vulnerabilities and ensuring that it's secure before it's deployed to production. Secure configuration management, where you talk about the infrastructure that is configured securely and that is free from vulnerabilities. And lastly, we also have incident response and disaster recovery. For that, it's important to have a plan in place for responding to security incidents and for recovering from disasters. In addition to these, you will have certain security tools that you can leverage. So those tools are mostly categorized under intrusion detection and prevention systems, which generally help in detecting and preventing unauthorized access to systems and networks. Vulnerability management, where you have tools like Veracode and various others that are basically scanning systems and networks for vulnerabilities and mitigating them. Like earlier, we heard about the Log4j attacks. Then security information and event management, collecting and analyzing security related data to detect and relate it to security incidents. Let's hear about some automation strategies for DevOps. In a DevOps environment, automation is used to automate as much of the software delivery process as possible, which includes testing, deployment, and infrastructure management. As we spoke about it earlier, one of the key automation strategies for implementing DevOps is CI/CD. The strategy focuses on automating the process of integrating and delivering code. By using tools like Jenkins, Travis CI, Circle CI, organizations can automate the process of building, testing, and deploying code much faster. This allows them to detect and fix problems early in the development process and to release software to production as soon as it's ready. Another automation strategy is infrastructure as a code, IaaC. This strategy focuses on automating the process of provisioning and managing the infrastructure. By using tools like Ansible, Chef, and Puppet, organizations can automate the process of provisioning the infrastructure and managing it faster and more efficiently by reducing the risk of human error. Then we talk about containerization. It is another automation strategy that is commonly used in DevOps. Earlier, I mentioned about Docker and Kubernetes, which organizations can use to automate the process of building, testing, and deploying containers. This allows them to deploy software faster and more efficiently, reduce the risk of compatibility issues. In addition to these automation strategies, organizations can also make use of certain monitoring and logging tools to automate the process of monitoring and analyzing the performance of their software and infrastructure. Certain tools that I've highlighted over here are, in terms of monitoring, you can see Prometheus and Grafana that collect and analyze performance metrics. And in terms of logging tools, we have the ELK, that is Elasticsearch, Logstash, and Kibana, along with Splunk that collect and analyze the log data. All right, so let's dig a bit deep into certain best practices around DevOps. And like I mentioned, coupled with testing, security, and automation. So in a DevOps environment, testing is integrated into the SDLC process thoroughly, and it's performed at every stage, like we discussed. To ensure that testing is effective, organizations should adopt the following best practices. Automate as much as possible. Automated testing allows organizations to run tests quickly and consistently, and it reduces the risk of human error. Next, writing test cases that cover all aspects of the software. This includes unit testing, integration testing, functional and non-functional tests such as performance, security, usability, where accessibility also comes in. Then we have incorporating testing early in the development process. By testing early, organizations can detect and fix problems early in the development process before they become difficult and expensive to fix later. Talking about security next, to ensure that security is effective, organizations should adopt the following practices like writing secure code. It is important to ensure that code is written securely and that it's free from vulnerabilities. It is important to test for vulnerabilities, manage the infrastructure securely, like we discussed earlier, and respond quickly to security incidents. For that, having a plan in place for responding to security incidents and for disaster recovery is very important. Next, to ensure that automation is effective, organizations should adopt these practices. Automate as much of the software delivery process. It should include testing, deployment, and infrastructure management. Then use tools that are easy to use and integrate with. Uh, this circles around the CI/CD tools that we discussed, infrastructure as a code, containerization, monitoring, and the logging tools. Third, monitoring and analyzing the performance of software and infrastructure. Using monitoring and logging tools to collect the information about performance metrics and the log data. By adopting these practices across testing, security, and automation, organizations can ensure that the software they are delivering is of the highest quality and meets the customer's needs. It's important to keep in mind that these practices are not static. They need to be continuously updated and improved based on the current needs of the organization and its customers. Some real world examples. So let's discuss these real world examples of successful DevOps implementations that have integrated testing, security, and automation into their best practices. These examples will mostly illustrate how organizations like Netflix, Etsy, ING, and Target have used DevOps principles and practices to improve their software development and delivery processes and deliver more value to its customers. Netflix, most of you know, is a well known example of a company that has successfully implemented DevOps. This company has adopted a number of DevOps principles and practices, including continuous integration and delivery, automation, and infrastructure as a code. If you know how the Netflix underlying architecture works, it's basically full of microservices which allow them to develop, test, and deploy individual services independently. This allows them to deliver new features and updates to their customers and more efficiently. Before Netflix adopted the operate what you build model, it had siloed teams, as you can see on the left hand side. The ops team focused on deploy, operate, and support parts of the software lifecycle, and developers handed off the code to the ops team for the deployment and operations. So each stage in this SDLC was owned by a different person. Finally, towards the right, you can see Netflix built an even better model where dev teams were equipped with amazing product tools and were responsible for the entire SDLC. Netflix practices are unique to their work environment and needs and might not suit all organizations. But some lessons that we learn from their strategy are: don't build systems that say no to your developers. Focus on giving freedom and responsibility to the engineers. Don't think about uptime at all the costs. Price the velocity of innovation. Eliminate a lot of processes and procedures. Practice context over control. Don't do a lot of required standards, but focus on enablement. Don't do silos, walls, and fences. Adopt, you build it, you run it. Culture. Focus on data. Always put customer satisfaction first. And my personal opinion, don't do DevOps, but focus on the culture. Looking at the other three examples that we have, Etsy. Most of you know it's an online marketplace for handmade and vintage goods. The company has adopted a number of DevOps principles and practices, including continuous integration and delivery, automation, and containerization. It has also adopted a culture of experimentation, which allows them to test new features and updates quickly and efficiently. This has allowed them to deliver new features and updates to their customers fast and more efficiently. ING, a financial institution, has adopted DevOps practices to improve their software development and delivery process. They also use microservices architecture and containerization to improve their delivery speed and reliability. And with the help of DevOps, ING was able to reduce the time it took them to release new features from several months to just a few days. And similar has been the case with Target, which is a retail company that has adopted DevOps across its development and deployment process. Now, one very important thing to note here is that these examples are not a one size fits all solution. Organizations need to find what works best for them and continuously improve their processes. So, let's talk numbers. According to a survey by Puppet, organizations that have implemented DevOps practices and automated their software delivery process have seen a significant reduction in the time it took them to deliver software to production. On average, these organizations have seen a 60% reduction in the time it takes to deliver software to production. According to another survey by Gartner, organizations have implemented DevOps practices and integrated testing into their software delivery process, having significantly improved the quality of software delivery. On average, these organizations have seen a 25% reduction in the number of defects they are delivered with software. A survey by SANS Institute found that organizations that have implemented DevOps practices and integrated security into their software delivery process have seen 30% reduction in the number of security incidents they experience. According to a survey by Accenture, Organizations that have implemented DevOps practices have seen a significant improvement in the overall performance. On average, these organizations have seen a 20% increase in their ability to deliver new features and updates to their customers, a 30% increase in their ability to respond to customer needs, and a 50% reduction in the time it takes to resolve issues. So, what's next? Well, there's serverless computing, low code automation, AI driven automation, GitOps, like we will see soon, infrastructure as a code, and DevSecOps that we discussed earlier. We have multi cloud environments, chaos engineering, and much more. I'll be free to discuss this maybe in the Q&A section or later. You can just reach out to me. I'll keep it short for now. Moving on to what most wanted DevOps tools. So I assume that now you have learned about DevOps in detail and understood the importance of coupling it with testing, security, and automation. So here are some most wanted or industry-wide recommended tools to use in a DevOps ecosystem. However, I won't go into details as this slide is pretty self-explanatory. So I'll allow you a couple of seconds to observe and capture these, or feel free to take snapshots for you to refer later. All right. So, yeah, that basically concludes my talk for today. Let's summarize what we have learned. Automation plays a critical role in enabling organizations to deliver software faster and more efficiently. Integrating testing, security, and automation into the DevOps process is essential for delivering high quality software that meets the customer's needs. We discussed real world examples like Netflix, Etsy, ING, and Target that have successfully implemented DevOps and seen significant improvements in their software delivery and development processes. Organizations that have implemented DevOps practices and integration testing, security, and automation into their software delivery process have seen significant improvements in quality, security, performance while they deliver software. Implementing a DevOps approach with a focus on testing, security, and automation requires organizations to take a step by step approach. Automating as much of the process as possible, writing test cases that cover all aspects of the software, ensuring code and infrastructure are secure, and using the appropriate tools, organizations can improve the quality to the optimum level. Remember, DevOps is a continuous effort. An organization should be prepared to adapt and improve their processes as necessary to meet the changing needs of the organization, the industry, and the customers. Thank you all for joining and being such a wonderful audience. I'm hoping that you found this session really insightful. Special thanks to Sangam and the Cloud Native Folks community to have me here today. Feel free to follow me on my social media handles, and thank you once again.
Thank you, Sangam, for sharing your expertise in DevOps security, testing, and automation, and summarizing it for us at the end. It was a really informative session. Thank you so much for your time and sharing your knowledge, and kudos to you for the excellent presentation with the real world examples. So, moving further to our next agenda, API testing made easy by Barkatul Mujauddin, and he is a pre-final year undergrad student who is passionate about technology and tech community, and as a developer relations intern at Keploy and Cube Simplify ambassador. So Barkatul is dedicated to helping others in the field and staying up to date on the latest trends and the best practices. In addition to his professional work, Barkatul is also the founder for Hack for Code, a community for sharing knowledge and ideas. And he is an Android developer and a DevOps enthusiast and enjoys sharing his knowledge and through the writing and the video creations. So he's always looking to connect for new opportunities and to share his ideas. So let's hear from Barkatul.
I'm audible. Yeah. So, good evening, everyone. Good morning and good afternoon. So, thank you for having me here today, and I'm honored to be speaking with all of you in DevOps India 2023. And I would like to share my knowledge. And so, here's my quick introduction. Uh, I am a DevRel intern at Kploy, and I'm a KubeSimplify ambassador. And I, with my few friends, are running a community called Hack for Code. So yeah, that's basically about me. So today's session is about API testing made easy. So before discussing how we can make API testing easy, first let us understand that why API testing is important for us, right? So let's go to that. Why API testing, right? So independent API testing can be performed independently of the UI, allowing for earlier detection and fixing of issues. Right? For example, if the API provides data to a web application, the API can be tested without the need to launch the application. This allows the developer to catch bugs and issues in the API before the application is released. Now, second point is API testing can ensure that the functionality of the API is working as expected, right? For example, an API test could check if the API is returning the correct data format or if it is properly handling errors and exceptions, right? Reusability. So why API testing is important? It supports reusability, right? So API test can be reused for multiple test cases, saving time and resources compared to manual testing, right? For example, if the API provides data to multiple applications, the same set of API test can be used to test the API's functionality and performance for all the applications at the same time, right? Now, let's move on to the next part, improved quality. How it is useful in improving the quality? API testing can help improve the overall quality and reliability of the application by catching bugs and other issues earlier in the development process. For example, if an issue is detected in the API, it can be fixed before it affects the user experience in the application that consumes the API. This results in a higher quality and more reliable end product for the user. So we have discussed about why API testing is important, but still, when we test API, our API, we face some common challenges. So let's discuss. The first challenge is it is hard to debug test cases, right? Debugging API test cases can be challenging due to complex nature of APIs and the amount of data involved in testing. Time consuming. Writing and maintaining API test cases can be time consuming for developers. The process of creating, maintaining test data mocks, or you can say test cases, can take up a significant amount of time, which could be spent on other development process, right? Yeah. Next point is creating testing environments. It is literally a common challenge. So creating a test environment that accurately mimics productions can be challenging. These can be time consuming and frustrating for developers as well. The next one is unrealistic data mocks. The test data used for API testing may not be realistic enough to accurately test production scenarios. Like, to address this challenge, it is important to use realistic data mocks in API testing to ensure that the tests uh, accurately uh, reflect production scenarios. Now we have seen common challenges around API testing. So, what if you can convert API calls from anywhere to test cases directly? Let's imagine this. So here comes into the picture Kploy. So what is Kploy? Kploy is a functional testing toolkit for developers. It generates end-to-end tests for APIs along with mocks or stubs by recording real API calls. So what it does is Kploy captures all the API calls and subsequent network traffic served by the application, and you can use any API management tool like Postman, Hopscotch to generate test cases. Kploy has native integrations with popular testing libraries like GoTest, JUnit. It covers code coverage will be reported with existence and Kploy recorded test cases and can also be easily integrated into existing CI pipelines. Kploy automatically mocks external dependencies for all CRUD operations with correct responses. Now you will not require mocks for dependencies like databases, internal services, or third-party services. Right? So with Kploy, you can safely replay, write, or mutate by capturing from local or other environments. Accurate noise detection. Kploy identifies noisy fields in the responses, actually like types, random values, to ensure high quality test. Right? As the application serves the API, Kploy reruns the API. Kploy reruns the API request with the captured dependency mocks. Kploy then compares the response to see Kploy then captures the to see like it compares the response to see yeah sorry yep, it compares the response to see if they agree or disagree. If any of the API responses are different, they are marked as random or non-deterministic fields. So let's see how Kploy works. Like once you start the application in record mode to capture API calls as a test cases, now when the application serves as an API, all the unique network interactions are stored within Kploy serves as a test case. And let's say you developed new application version v2 to test locally. Start the application after setting the Kploy SDK mode to test mode to replay all recorded API calls and test cases. Now, when the application starts, Kploy will download all the previously recorded test cases, API calls with a few second delay. When the application will try to talk to any dependencies like databases, routers, vendors, Kploy will intercept and provide the previously recorded dependency responses to you. Kploy will compare the API response to the previously captured response, and a report will be generated on the Kploy console. You can test with Kploy locally or can integrate Kploy with popular testing frameworks and existing CI pipelines as well. So yeah, that's it from my side, and here's the GitHub repo of Kploy, which you can check it out, and don't forget to give a star, and you can install it locally or check this cool and really awesome tool for API testing. It's no code, obviously. And if you are having any doubt, you can also connect with me on Twitter. I have dropped my Twitter ID here at Barkatul20. So yeah, thank you so much, DevOps India, for giving me this opportunity. Thank you so much, Sangam. Thank you so much, Shreya. Thank you so much, everyone. So, yeah, bye, everyone.
Thank you, Barkatul, for your informative session. And yeah, please check out the links that are mentioned by Barkatul, his GitHub profile. And feel free to ask any questions in the comment section. With this, we will move further to our next topic, building infrastructure for developers the hard way. So, our next speaker is Lior Mechlovich. He is the CTO and co-founder of AmberFlow.io. In previous roles, Lior was building and scaling great products at AWS and Informatica, focused on distributed computing, observability, and data platforms. Always an engineer, Lior enjoys building software and writing about software development, DevOps, and design and architecture topics. He is passionate about building software that makes developers and other engineers' lives easier by providing simplified access to larger scale systems. With Amberflow, he is trying to provide metering and usage based billing as a service with a developer first approach to make it seamless and easy to use as possible. Yeah, over to you, Leor.
Hey everybody, great to be here. Can you all hear me? I hope. See my screen and everything. Great, so I guess we can get started. Thank you so much for having me. As Shreya, thank you Shreya for the introduction, and we can definitely get started. So yeah, I've been working with billing systems for the last 3-4 years, working with AWS and Informatica before Amberflow. And today, as co-founder of Amberflow, we are building cloud metering and billing systems. But the main point of this session is to explain about what does it take to build a billing system. And it's a fascinating area, and it got a lot of changes in the last few years. I've been talking with many companies, many people, many brilliant people that build various billing systems. So I think that's an interesting sneak peek into this world. So what's actually really interesting here is it's changed a lot. It used to be very simple to do pricing, to do billing. You would sell something to a customer, he will pay you $100K, and you forget about it until the next year. That's not the case anymore. Every SaaS service that you're now subscribed through, if it's a cloud provider, of course, like AWS and GCP, like how they actually price their usage, their service, up to really every SaaS provider now, it's not just $20 per month, it's actually consumption-based. And the move to usage-based pricing, great as it is, and I'll go and show a few slides about how does that shift to usage-based pricing looks like. It presents a lot of new challenges, a lot of new interesting data challenges for us, for developers, for engineers that are trying to architect those kind of solutions. We're seeing usage limits, throttling, pricing based on tiers, and many things that we'll encounter. And I would like to show you guys common pitfalls that we saw along the years people are doing, and how to avoid them. That's kind of going to be our context for today. So just a high level why or how we see usage-based pricing going mainstream. A very interesting usage-based pricing state of the SaaS business, and how does that really taking over as a dominant model. And you can really see multiple customers. It started from the cloud providers and how they price their services based on consumption. But today we can see many companies, Twilio, Attentive, Snowflake, right? You can price based on compute, volume, SMS messages, number of hosts, all of those examples of companies that they only price you off what you use, which is consumption-based pricing, right? It aligns better with value. It's more flexible. You don't need to, start the year with how many hosts I'm going to have at the end, but just go and pay as much as you grow, which is, of course, great for customers. It is also more predictable, which is kind of surprising, but that we can go into this. So I don't want to talk too much about why moving to usage-based pricing, but mostly on all the challenges that it brings, right? As developers, though this is an example, DevOps developer know how hard it is to understand their bill, how hard it is to understand their AWS bill. And this is just a few examples, how EC2 pricing looks like based on instance type, how many vCPUs, memory, and all of that. Lambda, so this really, the time that a specific type of machines is up versus how long an invocation, a Lambda invocation works, and also like S3 with different tiers. So we can see right away this is going to be complex to build, right? Whatever we're going with, it's per region, per tier, different types of instances. It becomes very interesting, okay, to interesting challenges. And this is all pure usage based, right? And even if you're looking on more traditional SaaS models, even this is in this example, we're seeing Launch Darkly that has, a number of dollars per seat. But if you're really looking into the details here, even this that looks pretty simple, how many dollars per seat, and you just multiply that, you can actually see there's the details, right? So it's not really all free lunch, all free buffet once you pay this. Once you really get to details, it is tier, it is usage-based, it is limited to the usage itself. So which means for us, we actually need to build those things, right? We need to be able to track how much customers are using, which is not as straightforward as we might think. And this slide is going to accompany us in the next few minutes at least. And this is kind of to be the core of why usage-based pricing is hard. I know there's a few things here. We're going to kind of unpack every item here during this session. And it's all start from accurate usage tracking, right? We really need to be accurately measuring usage, which again, sounds simple, but we'll see how not simple it is. There are a lot of internal stakeholders to this data, right? Once usage-based pricing comes, everybody will look on it. Finance, sales team, they're going to want to predict, they're going to want to do revenue recognition. Product team is going to be really measured upon that. Because if until now it was like a nice to have, kind of, okay, who's using which feature? Do they use this feature or not? It's which was nice, it's analytics, but now it becomes accurate and it becomes much more important for the lifeline of the business, right? Because that's the revenue. The revenue will come from that. And truly, because it's a customer-facing data, because customers are using on this data, mistakes are costly. You really don't want to lose customer trust for overcharging them. If you wouldn't trust on your AWS bill, if you would think there is a chance that your AWS bill, your Datadog bill is wrong, that's very hard to overcome, right? So companies is really struggle overcoming losing customer trust once they overcharge their customer. And the changes are frequent. Price changes, companies find new dimensions to charge their customers. The product themselves changes and more predominantly today when it is usage-based. The deal structure change. So what actually you do with this, how do you price? Okay, it's usage, but you can maybe buy some prepaid amount before and get some promotion on that. We can tackle this a little bit later. Commitments is becoming more predominant. Exceptions are common, right? So, but just for this customer, let's make him a special price, which is always, we love that as engineers. And, even if we are not sure how much we actually need to price this service, we don't always know how much this is going to cost us. We're not sure about the margins. If we're doing a change in the price, which customers will be mostly impacted. So there's a lot going on here, right? Because it's a complicated problem with many dimensions. Now, even if you're looking on a very common AWS best practices diagram. It is pretty surprising. I mean, this snapshot has been taken like 3-4 years ago, and you can really see how this is kind of like how to take a service into a SaaSify a service. And you can see microservices and API gateway, and there's some identity management and deployment automation and monitoring in Matrix. But something that was not talked about a lot, at least in the last years until really moving to usage-based pricing, is this part, is the metering and billing, which is a core concept like Matrix, like monitoring, like identity management. But it was less obvious to people, and more organizations build this part by themselves many times across the years. And there's been a lot of good best practices that are not published. So that's kind of what I want to talk about. So I think we'll start with a good example about how, if you're doing something like an EC2, so it would like a simplified approach to understand why it's actually hard to build. We'll take how would an EC2 service, if you have a compute, like a database as a service or an EC2, how would you build a billing system for an EC2-based service? Okay, so let's try to imagine how EC2 metering and billing looks like. Okay, the price will depend on the instance type, on the region. There are probably 10 more, but let's keep it super simple. So just instance type and region for now. But we'll need to remember it's not just this number. If you are committing to a saving plan in AWS, you can actually get promotions for that. Okay, so there are some complications because we want to make it a bit more realistic, but we'll get to that. All right, so how would we do that? How would we architect such a system? We can start simple, saying every time an EC2 instance starts or stop, we will send an event. Right, there is a control panel. The control panel knows when the instance is stop or starting, so we can send this, an event to a billing service. Now, we should always remember what happens if we are losing events, because those things happen. Architect for failure will always happen. Failure is imminent. So we can overcome this. We can do a timeout, right? Maybe if something doesn't report for X time, it's lost. But that also doesn't work because EC2 can run for a long time, so a timeout here won't really help us. It's better to send heartbeats, like kind of keep alive events that the control panel will send like every minute or every 5 minutes, depends how you want to do it. But we will know that if we don't get any heartbeats for more than 10 minutes, for example, we can mark this instance as a stop. Okay, and that way we'll make it a more error-friendly, more incidents, so we'll not suffer from some incidents the control panel forgot to mention that the instance is down by keep on charging the customer, right? We want to minimize the overcharging. So that sounds reasonable, but it's actually not that simple because there's actually much more information. Like, does the control panel even know that, for example, the tagging? Right? So there's a lot of data. We're going to enrich the billing data, the usage data that needs to get enriched. A simple example would be tagging. Okay, and I'm starting to mention tagging just as a gateway for this because it's not just billing, as we said. We're looking on an EC2 instance and how long was it up? Great, this is good. It's the basic. But there's a lot of other feature, right? Because when you're moving to usage-based pricing, it's not enough just to bill, right? You actually need to show your customers as close to real time what will be the cost to be able to drill down to different cost dimensions, right? So in Cost Explorer, you are able to look on which EC2 instance, which regions, break down by instance types, right? You need to save all of those dimensions and tags to allow your user to explore and troubleshoot spikes, right? So it's not enough for us just to know how much time was used or how much this instance was used. We cannot just calculate the dollar amount and put it somewhere. We need to save the usage data, and not just the usage data, the actual usage and cost per machine, right? Think about that. And maybe we'll take a slide gateway here. Like if we're looking on the Cost Explorer, which is, again, is a great tool for a breakdown and trying to understand where does this cost coming from. There's a lot of different slice and dice, right? You can group by dimension, you can group by region, you can group by usage type. So there's a lot of data that you can actually play with here. right? And more than that, you can, and not just that, you can actually do usage. So it's not just cost, it's actually cost and usage breakdown, right? And you can have cost anomaly detection, and we're going to talk a little bit more about saving plans. So how do they actually recommend? I'm not sure, this is pretty new. I'm not sure if everybody saw that, but they actually can recommend you on committing to a specific amount. And right, so, and based on your past usage, to tell you what is you actually going to save if you buy a committed plan. So you will commit to X dollars amount, an average of X dollar per hour, and they will give you a promotion, okay? But all of this comes back to the basic usage data. Otherwise, you cannot recommend, you cannot drill down. So you really need to have this. And we'll go to also in details later on. You need to audit, right? Because again, if I'm as a customer saying, no way, this is, I don't remember I have this EC2 instance on this region up, I need to be able, as a support engineer in AWS, I need to come and say, okay, I know what happened, I know what's the resource, I can tell you when you made a start request, right? We need all the audit trail for this. Okay, cool. Cool. So let's, okay, that was weird. Let's continue here. So we'll talk about the Cost Explorer alerts to get alerted if there are spikes. You need that. Again, going to user base, you really need to give your customers all the right knobs to know how to handle this unexpectedly, because again, you give more power to developers, right? They can start machines, but then the cost can go wild. And you as a provider now that builds this billing system, it must be there. Otherwise, you won't get adoption to this usage-based model, right? So in order to give your customers a usage-based model, you must have good visibility and transparency to what you're doing. Okay, and there's going to be much more, but I'll stick here. Cool. So we talked a little bit about commitment, which is a very, very interesting concept. Again, even here on AWS, I think it's pretty good to know it anyway. They're actually telling you what happens if you're going to choose, recommendations, and what will happen if you're going to pay upfront or not upfront, and do all kind of calculations. But again, based on historical, right? So this will be based on the past. How many last 60 days, last 7 days, and think about it. In this moment, it goes ahead and query the 30 days usage and able to suggest something, right? To suggest a plan, which is pretty amazing. A lot of data behind the scene here. Cool. So it seems simple. We started from just setting stop and start, and then we really got into a bigger problem. Yeah, and as I said, it's not just about billing. What happens if we are, how do we do price modeling? So we're doing a change in our product. We're thinking about, should we make instance type X, or, doing a new region, or how would that impact pricing? How would different customers will be impacted? It's a process. Almost every time you're doing a price change happens. So hard to do it with no data, right? If you don't have the right usage data, which is accurate and per customer level that you can actually drill down to get top 10 customers that are going to be impacted from this price model. Cool. So there are some blueprints online to how to build such a billing, metering and billing, but I'm going to show why it's very simplified. So there is this example on the AWS blog that shows you how to build a SaaS metering and billing integration on AWS. And there's some good concepts here, so I think it's worth to take a look. Right, so this is our SaaS application. This is what we build. And every time there is a event, as we said, right, there's a billing event, an EC2 machine starts, we're sending an event, keeping it in a database. Makes sense? Every time there's a new customer coming, tenant onboarding, right? So there's a new customer, sign up, there's a provisioning step. Great, we put it in a database. That makes sense. And then we have some kind of an event aggregation, right? Because there's a lot of events coming in. We talked about heartbeats, right? Maybe every minute heartbeats. So you need to aggregate this, and I'm going to talk about this in a second, because that starts to be a bit more realistic, because you cannot send this many events to a database and then publish to a billing provider, as they put it here. So there is some event aggregation that every 5 minutes, for example, takes and aggregate how many minutes the machine is alive, right? So per machine, and then push it to a billing provider, like let's say Stripe, as for the actually billing or payment and that depends on what you want to do it. And here's a reference implementation. How will that look like, right? So we have the SaaS application is here, so it's kind of external to the system. Anyway, so we get events. Oops, sorry. So we get events, the event bridge, which are some kind of a topic that is being published here, and then we have some function that will save it into Dynamo. Right, there is a process billing event that saves it into Dynamo, the database. Same thing for a new customer. This is the onboard new tenant, saving in a database. Okay, so far this is the flow, and there is now a billing event aggregation function. It goes ahead and aggregate, and once every hour we can go ahead and use this function to push to Stripe. Okay, and sounds lovely. Sounds like it can work, but frankly, this is very, very, very simplistic. Yes, it has some really good, must have some kind of aggregation. There is some level of thinking here, but everything we talked before, right? How you do cost explore, how do you keep the dimensions, how do you make it useful for a commitment recommendation, tagging, who's enriching this pipeline, alerts. You really cannot do it here, right? There's no way that query DynamoDB in a way that will give you an aggregated form for the last 6 months, day over day for the usage, right? It's just not the right database, so it will not work. And of course, alerts and tagging and enrichment. What happens if we want to fix? That's interesting, right? So maybe a stop event came later, or maybe there is some error in the reporting and we need to fix. So very simplistic. That's usually what happens when you have like 5 minutes, when you're really trying to start this 2 developers for 2 weeks. Let's see what we get. Okay, so going back to the why billing is hard, I think we got a good example for this. And let me also highlight, right, we saw this slide before, and I want to highlight a few things that people are kind of commonly thinking about here, because we talked about matrix, right? Machine uptime, API calls, number of tasks run, all of those, which sometimes seems to people like monitoring and like observability, but it's really not. I mean, because the SLA themselves are very, very different, right? In the observability, what is the impact if your logs is missing? What happens if you duplicate the log line? It's really, nobody cares usually about those things, but what happens if a billable usage data is missing, or overcharge, duplicate billable usage, or even missing the data for 2 days? That's really, really hard to overcome. So the SLAs themselves are very different and the requirements are very different. So that's kind of the difference between a mate and what I call meter versus to matrix or monitoring observability stack. Okay, I hope we have enough time. I think we're getting into more interesting stuff. So this is why it's at least 10x harder than what you initially thought, right? Because everybody's thinking about this simple flow, some Lambda, some Dynamo, but it is really 10x harder of what you initially thought. There are many times, how do you handle system failures, how to re-ingest historical data, what happens when things fail. Very hard to just wing it. You cannot wing billing data. Performance becomes an issue very, very fast to be able to show, like we saw in Cost Explore, right? You really need to have this kind of aggregation, right? People are starting to then doing ETLs and doing kind of aggregation, moving this data to a more feedable database, which makes it, of course, more error prone. That's very, very standard to see. How do you handle disputes and some other pitfalls? Now, I really want to touch those things. I think there are 4 very important pillars, design principle for this, for building usage-based infrastructure. One core part is decouple metering from billing, right? So usage events, what happens is very different from prices and billing. Usage events are immutable. They happen. A machine started, a machine stopped, an API call happened. Those are immutable facts, while pricing and billing changes and always be changed and can be different modeling. So very important, the usage that you actually keep usage, keep cost per usage, but definitely different systems for that. Different end users, right? So usage metric are a superset. So you can have 10 meters and only 5 of them will be billable. Okay, that's kind of how we should look at that. And accuracy, right? So the system must be idempotent, so you can really retry, re-ingest, backfill, run again without fearing to overcharge or undercharge, right? And idempotency and deduplication comes together. So the source systems, the EC2 control panel can trust the system to be idempotent and dedupe. So he can send the same records again and trust that it won't be previously consumed, it won't be duplicate data. Okay, that's very important to keep the system. So even if there is an incident, you don't really have to know which records are already processed or not. You can always replay them. Auditability. So it's not just enough to keep the aggregated, like we saw before. We really need to keep the audit, right? Even if you're sending like an SMS, you really need to store the target phone number, right? Which makes sense for us to send, but that actually goes to all those systems. So you need to keep the audit record, both for audit and disputes that the customer will ask, or for replaying the data. Okay, so that's important. And scaling, very hard to give this real-time view easily. This is something that gets out of control very fast. Yeah, a little bit on, I think we have a few more minutes, a little bit about how usually applications report usage, because we say, okay, there are events, the EC2 control panel sends event. There's pretty fascinating patterns here. Is it based on logs? Like those are the three more core ways to report usage, to report meter events. Could be a part of logs, like there's some downstream process that based on a pattern makes it into a billing event or a meter event. And there's messaging, so you have some kind of an SDK that puts a billing message on Kafka or an SQS, some kind of a topic that the billing service downstream consume from that topic and aggregates. And more basic will be database queries, right? You have a repository, your app has a repository, you pull from this repository, from this database every hour or every day to be able to push it into a billing service. Okay, those are the three common. Those are the common issues with them. So everyone has its own issues, I would say. Of course, on logs, the most problematic thing is, it can really break easily. A developer change a log line. That's very not nice to lose all those billing events. Messaging, which is pretty common, publishing to a Kafka or to a SQS and so on. It's easy. People are doing it a lot. Really important to do the once and only once processing, which is, has its problems, as we said, overcounting, undercounting. Really important to fill the idempotency in those cases, but it's great when because it's still inside the app, just sending events, and then the downstream system will handle it. Database queries is problematic sometimes because it's really hard to handle errors, right? It's usually kind of somebody else, right? So messaging, it's still inside of your code. You really control when you send those billing events. There is more developer friendly here. Database queries is usually some DevOps or somebody else take it from the database, from the application repository, and it can cause problems. Again, how to encounter failed jobs, all those things that you do aggregate and not streamline, tends to be a bit more hard to recover from errors. Okay, still possible. People are doing it, but usually when you want to touch, you don't want to touch the app code that much, and kind of want to do it externally. Yeah, just mentioning why large data scans are why it's a performant issues, because per customer it's easy, right? Per customer it's actually pretty easy to know, okay, give me the usage for this customer, but we forgot the internal use case. I want to see, as an EC2, right, as my application runs, I want to see my top 10 customers this week, or the top 10 customer trends in the last 6 weeks, right? So this is my app, but across customers, and I want to show top 10x. Now, this will, even if you start to think it would start, I only want to look on, there's a bill, I only want to generate the bill. Really, to make this kind of more aggregative analytical queries is the lifeline of the business. I really need to see who are the new customers, whose customers are doing more, which part of the product is doing better. So really important to keep that. And all of a sudden, we also have active unique usage, which is a different problem, right? How you measure unique, for example. But that's a metering service. When you build a metering service for your organization as a platform, as a platform service, it's not just compute, it's not just storage, it's actually becomes like doing distinct count, for example. Okay. Usually when you have this kind of a platform service, a billing service, you create SDK. The SDKs themselves need to be smart to do retry, to do batching, to do async, so not to block the main thread. That's usually when there is an organization that builds this billing service. Those are how the SDK properties handle failover, handle network issues. No, that's that every service can just won't reinvent the wheel here, right? So just use an SDK that the billing service will give him. A few interesting use cases here was how do you track duration? If you really think about S3 storage price, which is gigabyte hours, very hard to understand, but it is the average storage used throughout the month. Meaning if you put 10 gigabytes for 15 days and then nothing afterwards, you only pay for 5 gigabytes. So it's gigabyte hours, not easy to calculate. And as we said, there's all this kind of monthly unique users, unique seats, like Slack charges based on how many unique users were in that month, right? So it's not that simple. You need to remember who was it. You need to show this across the month, like as we go. So it's not just unique as a one number, but actually unique per day. And as its own, like this is an example of Segment and how they track monthly tracked users. So there's different sources, but basically they want to dedupe based on the user ID. Very interesting stuff. Yeah, so I hope that was interesting for you guys, and I kind of conveyed why usage-based pricing is interesting and a very interesting data problem. Yeah, and so reach me out, reach me. That's what we've been handling with Emberflow in general. Feel free to ping in any billing-related usage-based pricing questions.
For another great session. Thank you for explaining the popular usage-based infrastructure billing and its design principles in depth. It is really applaudable for all the speakers who took out time from their busy schedules to be here today with us. And I believe the audience is busy noting down the key points. All right, moving on, we have Sagar Utekar, who has experience with cluster deployment and orchestration technologies with Chef, Salt, Ansible, Docker, Kubernetes, Helm, OpenStack, Jenkins, all the DevOps stuff. And he has experience with monitoring and alerting infrastructure with Grafana, Prometheus, Slack, Datadog. So his topic for today that he's presenting is monitoring Kubernetes cluster with Prometheus, Grafana, Alert, and Alert framework. Over to you, Sagar.
My name is Sagar Utekar, and today I'll be talking on monitoring Kubernetes cluster using Prometheus, Grafana, and Alert Framework. Um, okay, so to start with, little bit about me. I'm currently working at VMware as site reliability engineer. I'm Docker Pune and CNCF community leader. I have very good experience and I love open source, and I firmly believe in power of community execution. Um, yeah, so recently I have participated in Google Summer of Code as mentee, and also have been mentoring and doing administration for different open source and GSOC projects. Um, I also completed my all Kubernetes certifications, Prometheus and Terraform certifications. Yeah. So moving on to next slide. So what's on today's agenda? We'll talk about why monitoring is important, how we can do Kubernetes cluster monitoring. I also learned few rules or the golden signals for monitoring from sorry books. So I'll share a little bit about that, and I will also do some demo. Okay, so why Prometheus monitoring is important, or why monitoring in general is important, and why we should use the Prometheus for Kubernetes cluster monitoring. So Prometheus is leading open source monitoring tool solution which has the alerting capabilities. So basically, you can use the Prometheus Grafana, these open source tools for free. You can do your setup and you can monitor your Kubernetes cluster, or you can monitor your non-containerized or the containerized environment, and it has the capability to alert you on different thresholds or different conditions which you set for the alerting. So basically, you need one HTTP endpoint slash metrics and Prometheus Alert Manager, and Prometheus will create metrics for your Kubernetes cluster or the server from that endpoint, and it will store those metrics into one of time series database which this Prometheus uses. So once you collect these metrics, you can set different conditions to trigger an alert, and you can send these alert notifications to email, Widget.io, or Slack, so that you can get notification and um, uh, troubleshoot those issues, right? So why we need monitoring? Let's consider an example of having very large microservice based, or even in general any non-microservice based application which has the front end, back end, lots of services. So it's very important for you to understand what's going underneath or inside your system, right? So to have that visibility, we need a consistent monitoring of highly dynamic containerized environment or non-containerized environment, which will give you exact idea of what is happening, and it will help you to know what is causing the issue and why a particular thing is not working. So let's say you have a website which is showing that there is some internal server error, but on the backend side, what is happening that you don't know if it is down or if it is not working because of some network issues, because of some latencies, because of some database issues. So to debug or to get more visibility into your system, you can do you need a monitoring of your system, right? So instead of manually trying to troubleshoot across multiple components of your system, it will exactly help you to pinpoint what is causing, what is the root cause of the that problem, and it will help you to debug that issue quite faster. So it will also help you to save some time and some money and a lot of efforts, because you will not need to go into entire system components and to check what is going wrong and what is happening. So yeah, so with Prometheus, you can automate everything. You can set up these Prometheus with simple commands, and you can monitor your system. It will help you to identify the issues in your real-time system, and it will also help you to identify the potential issues which will happen, which can happen in the future. So you can prevent those issues. Let's say there is a issue with some database, your database is quickly filling. So in that case, you can set an alert on 50% usage of your database. You should get an alert. You can clean the database, or make some space into your database so that your system can run smoothly without any errors. So all those kind of things you can do with the monitoring, and why it is important. Okay. I'll also talk about how you can do this monitoring in our demo part. So I have created this um, README, which will walk you through what the steps you will need to follow exactly. Why Kubernetes cluster monitoring? Because in production cluster, there are so many nodes, there are so many ingress components, there are pods, there are deployments. You need to understand what's the current situation of your Kubernetes cluster, what's happening in your Kubernetes cluster. If all the pods are running fine, all Kubernetes nodes are running fine, auto scaling, all the security part and everything is fine, working fine. So that's why you need a Kubernetes cluster monitoring. um, so you can collect Kubernetes cluster metrics. You can process them. Actually, Prometheus will do that for you. It will aggregate those metrics and display real-time quantitative data about your Kubernetes cluster using different kinds of metrics, and you can use those different available metrics of your Kubernetes cluster to check the health of your cluster and to monitor your Kubernetes cluster. So let's say you have a thousands Kubernetes cluster nodes. You will not go into every Kubernetes node and check what's happening, if it is up or not, if its CPU is working fine, or if memory is enough or not. So instead of that, checking thousands or 5,000 of nodes individually or the pods individually, you can set up a Kubernetes cluster monitoring, and it will help you to debug the issues and to get a better visibility of Kubernetes cluster. Right. So I'll share a little story about one of the incidents uh, which helped to this Kubernetes cluster monitoring helped us to debug in one of my projects. So we have a very large Kubernetes cluster and different production and testing Kubernetes cluster environments. We got an alert, a pejorative notification at 3 a.m. in the morning, and you know how it is disturbing uh, if we get a call in the early morning, or like if our sleep get disturbed, right? So got a call at 3 a.m. in the morning, and um, we joined a meeting to understand what exactly happened, why got an alert at such an early morning. Because we had this entire Kubernetes cluster monitoring setup and Grafana dashboards and everything set up, we knew that what exactly happened and why this particular issue happened in our Kubernetes cluster environment. So the issue was related to some database was quickly filling up, and we uh, cleared some spaces. We unwanted database entries we removed, and then our Kubernetes cluster started running fine. So to avoid such kinds of unnecessary calls at midnight or some, right? So you can have a Kubernetes cluster monitoring properly set up, and you can save this your Kubernetes cluster environment. You can get a long-term trends analysis with your Kubernetes cluster monitoring. Let's say uh, you have a website like a Flipkart or Amazon, which gets a huge upcoming request at certain time of a week or a month. Let's say there is some function a festival in India, so they will get lots of input requests at the time of that festival time. So with properly monitoring setup, you can see what is that time of the month, or what is the time of that week when you get lots of requests, so you can have your infrastructure set up for auto scaling, which will um, help to run your system very smoothly. You can set up alerting with Prometheus, which you can also build the dashboard with the help of Grafana. I'll show you the Grafana and Prometheus dashboards as well, and it will help you to debug the issues faster.
So these are the four golden signals which I learned from the SRE book by Google. So you need to consider these 4 points: latency, traffic errors, and saturations. So if you are not sure about what metrics you should set up for your any environment, then consider these four parameters while setting up the monitoring for your infrastructure, and it will help you to set up at least basic metrics which are that should be for your system. So consider the latency example. So you should have a metrics related to latency to understand how much time your service is taking to process any request, right? So it is important to track error latency as opposed to filtering out errors. Like you should understand the latency taken for your error latency taken for your application. So there should be some latency related metrics. You should have metrics related to traffic to understand how many requests are coming per second, or how many transactions are happening for your databases on database per second. Um, and then you should have some error related metrics to understand the rate of requests that are failing very quickly, and to set to have few more metrics related to situations to understand how quickly your database is getting filled. So to understand maybe after 4 hours, this is the current situation of your database, but after 4 hours it will fill very quickly. So to have that kind of predictions of your service components, you should have the metrics related to saturations as well. These are the four components you should consider while setting up monitoring for your any system. It can be Kubernetes or it can be non-containerized environment as well. This next slide is related to Prometheus architecture. So there are a few components in Prometheus. Our main component is Prometheus server. There is a push gateway. There is TSDB, which is database, time series database. There is alert manager. Prometheus also comes with the UI. It's not good as Grafana, but yeah, it also has the UI, so we'll talk about that. And if you see here, this is the main component Prometheus server, which consists of retrieval, TSDB, and HTTP server. So we'll talk about those components. There is a push gateway which interacts with the short-lived jobs, and here is the main component, main thing or the property of the Prometheus. So it collects or the pull metrics from the your targets. It can be Linux server, Windows server, and also from push gateway. It pushes the metrics, collected metrics, to the alert manager, which in turn sends notification to different integrations with PagerDuty. It can send email, it can send notification on Slack as well. So I'll show you how I have configured it to send the notification to email and Slack, uh, and also show you the Grafana dashboard. Right, so these are the system components of Prometheus. Main component is the Prometheus server, which actually monitors and scrape metrics from your targets and then store it into a time series database TSDB. Data retrieval pulls the metrics from slash metrics endpoints of registered targets. So you basically need a endpoint on your target slash metrics, which will which will provide the metrics related to your system. And these data retrieval components will start pulling the metrics from those metric endpoint. It should have a particular format which Prometheus will understand, right? And then targets can be anything. It can be your Linux machine, it can be your Windows machine, it can be Kubernetes cluster, it can be your database services, right? Metrics. Some of the examples related to metrics you can monitor. We can monitor CPU related metrics for a system. It can be memory usage or disk space usage. We can have metrics, application metrics as well. Or exceptions count of your in your application that we can monitor. So there is a component here, service discovery. Prometheus provides a service discovery feature uh, which can automatically or dynamically identify the uh, dynamic nodes added into your Kubernetes cluster or file system. Uh, for file system discovery, it will automatically return new files added into your directory which you are currently monitoring. And in case of Kubernetes service discovery, it will dy- dynamically nodes, it will start scraping. So this is the best feature of Prometheus. You don't need to provide the or the hardcore, the names or the IPs of your Kubernetes nodes, because it's possible that those IPs or the names will get changed over the time, or it cannot, because of auto scaling of Kubernetes cluster. There is another component called exporters. Exporters help to collect the metrics from third-party systems which don't provide the slash metrics endpoint. So in case of in that case, you can use the exporter. Like there are different exporters available. Uh, by the Prometheus, there is node exporter which can help you to scrape the metrics related to nodes. There are HTTP endpoint exporters or the Redis exporters which you can use to scrape the metrics related to Redis, because they don't directly provide the slash metrics endpoint. And then this exporter will collect those metrics from the system with third-party system, and it will convert those metrics into Prometheus, which Prometheus can understand, and then expose on the slash metrics endpoint. I hope I'm audible. Okay. Uh, the last component which is important in Prometheus is Alert Manager. Alert Manager groups or gets the alert notifications from the Prometheus and then send those notifications to different integrations. Prometheus can send alert notifications to email, PagerDuty, Slack, and it has different kinds of this integration receivers available. Okay. So basically, there are four major metrics you can have in your system. Counter, which can either which will give you the count of request or error count, which will always increase. Those kind of metrics you can for those kind of metrics, you can use the counter type of metric. Gauge metric, which can decrease or increase. So consider the example of memory, which memory size can increase or decrease. So that those kind of metrics you can use with the gauge metrics. Histogram is like a sample observation of current system. What is the request duration or the response time, response size of your uh, uh, right? So those kind of metrics you can measure using the histogram. Summary is same as histogram, but it also provides the total count of observations over the histogram. So you can use the summary metrics if you want the additional metrics over the histograms, total count metrics. For the histogram, you can use the summary metric. Uh, then there are, if you want to monitor the application related metrics, then Prometheus provides the client libraries for different languages. You can use those client libraries for identify Prometheus and expose the slash metrics endpoint from your application. Then this Prometheus will scrape those slash metrics endpoints of your application and provide the application related metrics as well. So next thing is demo. I have used the Kubernetes, Helm, Prometheus, and Grafana in this demo. So I'll quickly walk you through what are these tools: Kubernetes, Helm, Prometheus, Grafana. Kubernetes is open source container orchestration platforms which automates many of manual process which involved in deploying, managing, and scaling containerized application. So basically, Docker containers, there are so many Docker containers. You need auto scaling, you need some deployment related help, all these features and the container orchestration features which comes in Kubernetes. So we use Kubernetes for that. Just in simple words, Helm is the package manager for Kubernetes. Where when you use the Kubernetes, there will be a lot of files related to service deployments, pods, config maps, secrets, and all. So instead of having it's sometimes it is very difficult to manage all those files. You can use the Helm package manager to manage your Kubernetes components files. And Prometheus, as we talked, it's open source tool for monitoring and alerting. It's a very popular tool. And Grafana is for visualization of your metrics. You can have a integration of different tools like Prometheus, CloudWatch, Azure Monitor, Postgres. You can collect all those metrics and you can create a different visualization graphs. You can plot those graphs and Grafana, and it will help you to see the visualized graph on Grafana dashboard. I'll show you how it looks on Grafana. Before conversion, no, I'll walk you through a demo before that. So this README file I have created to walk you through what are the steps you should follow for Kubernetes cluster monitoring. So these are a few prerequisites we need. We need a kubectl, Docker, and Helm. Uh, I have set up this Kubernetes cluster using Minikube. It's a single node cluster, which you can set up easily. You can follow these steps on Minikube documentation, how you can install Minikube and all. So I'm using Mac, so I installed the Minikube using this single command, and after that I started Minikube single node cluster. I have this Minikube cluster running, so I'll quickly show you here. Uh, this is my Minikube and Minikube status. So it's currently running, and we can see how many nodes currently running in this Minikube cluster using kubectl git nodes. There is a single node. This is a single node cluster, Minikube cluster. It's in ready state and it is working as a master control plane and node. Right, and the version of Kubernetes cluster is 1.25. Okay, so we have Kubernetes cluster ready. We should start monitoring it. Um, the next thing we need to do is setting up Prometheus using Helm chart. So I'm going to use the Helm chart, which is here. I already have this.
Hello, Saga.
So
Sorry to interrupt. Can you change your screen? I
uh,
think you are sharing your slide.
oh, okay. Sorry.
Yeah, go ahead.
Share screen. Is it visible now? My screen?
Yes, it's visible.
Okay, perfect. So I was talking about this README file which I set up to walk you through how we can set up this Prometheus cluster, Prometheus monitoring for Kubernetes cluster. This is a prerequisite. We need a kubectl, Docker, Helm, and Minikube. For demo, I'm going to use the Minikube Kubernetes cluster. It's a single node cluster. I have already set up this Minikube on my MacBook. First thing, we need to start Minikube cluster using Minikube start command. It will use the container engine as Docker, and it will install the latest Kubernetes cluster to the So as showing you this command, how many nodes we are going to check how many nodes running in Kubernetes cluster. So run this kubectl get nodes command. It will show you is a single node minikube cluster running with 1.25 version. Right. So after that, we need to set up our Prometheus. So I'm going to use the Helm to set up our Prometheus server. So I have already set it up to save us some time. First command we need to run is the Helm repo add. Once you add the Helm repo in your uh, system, you can install Prometheus using Helm install Prometheus chutney using this command. We can see this Prometheus. This Prometheus chart is already installed using Helm ls command. Once that is done, for exposing Prometheus service on a system, use the minikube service Prometheus server np command. After that, we need a Grafana for visualization. Same steps we are going to follow. We will first add the Helm repo, then install the Helm chart using Helm install Grafana and Grafana chart name. Once that is done, I already installed it. You can see here Grafana and Prometheus is installed, Helm chart is installed. You can see the pods running. So these are different pods which will get installed once we install the Grafana and Prometheus Helm chart. So first one is related to Grafana, and you can see all these components related to Prometheus. It has alert manager, it has website metrics, node exporter, push gateway, and server. Okay. Then we will expose the Grafana service to access it from system. And once that is done, I have this Prometheus and Grafana running here. So uh, we can see this is how Prometheus dashboard looks like. You can see the alerts configured. So this is a demo alert have configured to send the alert notifications if the pod memory is high, um, and we will send this notification to Slack as well. So currently it is in firing state, and you can also see the graphs, different metrics related to pod. Once you start typing, it will show available metrics and the type of metrics. So you can see that this is a counter metric. It will show the count of all security violations total. So this is the count too. Okay, so there are so many metrics. It Prometheus will automatically add you for you as well. Related to Kubernetes pods and Prometheus itself and deployment to kube deployment created. All this is beautiful, right? But this is not beautiful as Grafana. I will show you Grafana as well. So first we'll try to log in into Grafana, and before that we need to get a Grafana password, default password. So I'll log in into Grafana. Once you set up Grafana, so then you'll need to set up your Prometheus data source. Go to data sources, select the Prometheus type data source, and provide the URL of your Grafana server, Prometheus server here. So from Prometheus data source, we are going to take the metrics. That's why we have set up this data source Prometheus. Once that is done, we will create a dashboard, or we can import the dashboards which are freely available. I have imported this Kubernetes cluster monitoring dashboard, which provides me details about my Kubernetes cluster. See the current cluster pod usage, CPU usage of my cluster, this memory usage, disk space usage, how many deployments are currently running, what are the deployments available in my Kubernetes cluster. Um, there is a concept of namespace, so we can change over the namespace and see uh, what are the components and the different graphs available for that namespace as well. There are only one replica in this cube system namespace, and again, all this matrix is beautiful, right? You can create this kind of graphs using Grafana, and then also to send the alert notifications, you need to configure the config map. So, there are different config maps available for Prometheus. This is the main one. I'll just quickly go through this config map, what it does. See, here we set up a receiver for our alert. So we will send the notification using this receiver to Slack. We have set up the API URL, and using this email receiver, we are sending email notifications once we get any email alert. So this part we need to set in alert manager dot YAML or alert manager configuration, and in Prometheus server config map we need to set up different alerts. You can set up different alerts. So this is the demo alert I showed you for high pod memory usage. So once that is done, you can see here that I have started getting Slack notifications. I'm also getting email notifications with these configurations. Right. So yeah, that is how we can set up Kubernetes cluster monitoring using Prometheus, Grafana, and Alert Manager or Alert Framework. Um, and to clean up your resources, you can run this command: delete the Grafana Prometheus and delete the Minikube cluster. It will free up your resources. Um, okay, I'll stop sharing the screen and go back. So to conclude this session, keep it your monitoring as simple as possible. It should be reliable. It will help. It should help you to give you insights about your system, visibility about your system. Uh, and yeah, that's the main point. Keep it simple and easy. It should not be very complicated. You should not add unnecessary all the metrics which are available in the system. You can block those metrics to keep your system simple and concise. So to connect with me, you can connect with me on LinkedIn, or Twitter, and GitHub. That's about this session. Um, so apart from that, as I said, I'm running this Docker Pune CNCF community meetups, and there are devs meetup which runs every month. So I'll drop you links to our upcoming meetups so you can meet me in person, and we can also learn about this Docker Kubernetes cloud native technologies. So yeah, thank you, Sangam. Thank you. DevOps India and CloudNativeFolks for this opportunity to share my knowledge with this wider community. Yeah, that's
Thank you, Sagar, for yet another informative session on Kubernetes cluster monitoring and Grafana alerting demo, which comes really handy. And we have covered a lot of ground today, and I hope you are feeling inspired and have a better understanding of how these approaches can help organizations deliver high quality software faster. So next we have our last speaker for the day, Shubham Srivastava, highlighting observability microservices using open source system solutions. So Shubham Srivastava is a leading developer at relations at Zen Duty, which is an advanced incident management and response orchestration platform. He takes pride in making mistakes and learning from them, as we all should, and advocating for best practices for organizations setting up their DevOps, SRE, and production engineering teams. He's zealous and eternally curious professional, fascinated by stories from DevOps, incident management, and product design, and hoping to solve the real world problems with his skills and technology. Apart from this, as his hobbies, he's also a writer, orator, and a hopeful comedian. So let's welcome Shubham Srivastava.
Yeah, hey everyone, and welcome to my talk about observability of microservices using open source tools. Hope you're having a good time at the conference so far, and that you'll take away something valuable from my talk as well. So, another quick introduction to break the ice. Shreya did do a pretty good job explaining this, but yeah, I'm a developer relations engineer at ZenDuty. It's an advanced incident management platform, and I'm just an expert at making mistakes, learning from them, and making sure that more people around me do not make the same mistakes. Uh, yeah. So, what is this talk about? Firstly, we'll have a quick brief on observability, something I'm sure the brilliant speakers before me must have done a good job covering. I think Sagar did a really good job covering the tools, so I can focus more on the instrumentation part of things and the correlation as well. Then, why we need observability from day one. And then we're going to be setting up an observability system using open source tools in record time. And finally, we'll talk about what comes after you have observability set up, something that I feel isn't really covered a lot. So again, what is observability? It's the ability to measure the internal states of a system by examining its outputs. So observability gives engineers a proactive approach to optimizing the systems. It provides a connected real-time view for all the operational data in your software systems and gives you the flexibility to ask questions on the fly. Uh, and the most important part over here is having to know what questions you need to ask. And observability is not just that, it's also about understanding the service level required to meet customer needs and instrumenting the necessary components to ensure that the desired level of performance is achieved. It's not about collecting a colossal amount of data or attempting to measure every triviality of your system. Rather, it's about using the right metrics to track and monitor the key performance indicators that matter to you and adapting the system when necessary to meet customer expectations. So, why do I keep hearing about it all the time now? Simply put, software complexity is increasing at an exponential rate. And very fair question. We've been around for a considerably long time now. The buzz around the world has begun to catch on only very recently, like about 5 to 6 years ago. And like, why? Why now? On the infrastructure side, microservices, polyglot persistence, and containers are enabling the decomposition of monoliths into agile, complex, ever evolving systems. And meanwhile, on the product side, platforms and creative solutions are empowering users to do new and ever exciting things. However, it creates challenges for the developers to make sure that your components are stable and reliable. And like as recently as around 5 years ago, most systems were much simpler. You would have your classic LAMP stack, maybe one big database, an app tier, web layer, a caching layer, some software load balancing, and you're pretty good. You could predict most of the failures and craft a few dashboards that would address nearly every performance issue that you have. And your team didn't spend a lot of time chasing unknown unknowns, and finding out what was going on and why was pretty much generally achievable. But now with a platform or microservices architecture, millions of unique service users and apps, you have a long, fat tail of unique questions to answer all the time. There are many more potential combinations of things going wrong, and sometimes they sympathetically reinforce each other, making it all a mess. And now, why do we need day one observability? Can't I just wait for something to happen? Why am I solving a problem that doesn't even exist right now? But when environments are as complex as they are today, simply monitoring for known problems doesn't address the growing number of new issues that arise. These new issues, the unknown unknowns, would not be measurable without an observable systems. You don't know what is causing the problem, and you don't have a standard starting point to start diagnosing your issues. And without deep observability, it is natural to make assumptions about production system behavior, including what we think may be potential performance bottlenecks or failure scenarios. And when failures do occur, we are often in the dark as to both the cause and impact of the potential fixes. This leads to wasted time and effort, jumping from one theory to another and one change to another change without fully understanding how it's impacting a system. And if customers are impacted, most importantly, the cost of this guesswork can be sky high. In production, Kubernetes does help to recover from some failures, but there are many scenarios that can cause the system to run suboptimally or fail continuously even. And even when service availability is maintained, performance bottlenecks can result in premature auto scaling, which results in an excessive use of costly cloud computing resources. And indeed, it is the case a lot of times where the first sign of failure in a non-observable system is a huge, colossal cloud computing bill. And now, without any further stalling, let's move on to the meat of it, building a complete open source solution for extracting and shipping traces, metrics, and logs, and correlating between them. So a few prerequisites that we'll need to fulfill this demo. First up, Kind. Kind is a tool for running local Kubernetes clusters using Docker container nodes, and it was primarily designed for testing Kubernetes itself. So if you have Go and Docker installed, all you have to do is run this command and install and run Kind locally. I'll be sharing all links, snippets, and resources I mentioned in the talk in this gist, whose link I've just mentioned below. You can find all the relevant information you need to enact this out later as well. Next step, we have kubectl, your friendly command line tool, which allows us to run commands against Kubernetes clusters. And finally, we have Helm. Helm helps us manage Kubernetes applications via Helm charts, which make it easy to define, install, and upgrade even most complex Kubernetes applications. So let's move to installing the observability backend. And as there is currently no one database that can store traces, logs, and metrics, we'll deploy 3 different databases and a visualization tool. So firstly, previously covered, we have Grafana for dashboards and visualization of the data. We have Prometheus, as mentioned by Sagar. It records real-time metrics in a time series database, has high dimensionality, flexible queries, real-time alerting, your whole 9 yards. Then we have Loki, which is a horizontally scalable, highly available multi-tenant log aggregation system. It was pretty much inspired by Prometheus. And finally, we have Tempo, which is an easy to use and high scale distributed tracing backend. It is very cost efficient. It only requires object storage. And naturally, it's very deeply integrated with Grafana, Prometheus, Loki, and the CNCF infrastructure. And now we need the observability control plane. This will automatically instrument our application. And for that, we'll be using Odigos. Odigos is an open source observability control plane. Uh, it helps us in two ways essentially. Firstly, automatic instrumentation. Odigos automatically instruments our applications and produces distributed traces and metrics without any code changes. And then we have collector management. So Odigos also automatically deploys and scales our collectors according to application traffic. That means that there is no need to spend time deploying and configuring collectors. And now, for this demonstration, a target application will be a microservices based application written in Java or Python. And we'll be using a fork of the Bank of Anthos example application, which was made by Google. You can find the link in the resources. It looks something like this. It's a basic banking application with all of this dummy data flowing in that we'll use to visualize how a monitoring system would work. Yeah. So now you can deploy the same by simply running the following code, and you're pretty much good to go. And to install the observability backend, we'll execute this Helm chart. It deploys Tempo, the traces database, Prometheus, the metrics database, and Loki, as well as a pre-configured Grafana instance with a a single command. And all you have to do is just execute that. And once our application is up and running, or observability databases have been set up and are ready to receive data. So now we'll install Odigos as the control plane to collect and transfer all these logs, metrics, and traces from our application to the observability databases. To install Odigos, again, we'll use Helm charts. And after all the pods in the Odigo system namespace are running, all you have to do is open the Odigos UI by running the port forward command that's listed over here. Once that's done, all you need to do is navigate to the localhost 3000 port, and you can see your Odigos up and ready to go. So now there are two ways to select which applications Odigos will be instrumenting, which is first one is opting out, which is instrumenting everything. Every new application that you add in the future as well will be included by Odigos. You can still manually choose things that you do not want to include. And the other one is opting in, which is only choosing a certain few applications that you need to be monitored. For the sake of simplicity, in this tutorial, we'll just be using the opt-out mode. And yeah, so now we'll look at what Odigos looks like. It's a pretty basic application that helps you connect your metrics, traces, and logs. All you need to do now is go to destinations and make sure that you added Loki, Prometheus, and Tempo. There are these URLs that you'll need to put in, and these are again mentioned in the gist that I'll be providing. And yeah, just wait a few seconds for Odigos to finish deploying the required collectors and instrument the applications. And after this, the last step would be to explore our observability data in Grafana and see and correlate the metrics to traces to logs and basically measure how an application behaves. To do that, we'll now port forward a Grafana instance by running the following command. We'll enter admin as the username, and for the password, you'll have to enter the output of the following command on screen. Please note there's a percentage sign that gets appended to this string. Make sure that you remove that once you're using that string. And once that's done, we're now finally ready to see the power of monitoring. So we'll just go to Grafana real quick here. This is a dashboard that Sagar very well familiarized you with. Firstly, we'll just go to explore and see a service graph of our microservices. To that, we'll go to Tempo over here, and we'll click on service graph and just run this query. So you have a node graph of all the applications that are running and interconnected right now. So now to see some metrics, we click on the balance reader application for Essence and choose request rate. And yeah, there you go. Those are the metrics that you need to measure how your application are performing. There are three kinds of metrics that Odigo supports right now. Firstly, metrics related to the running of the application, which is the number of HTTP requests, latency, DB connections, etc. The second is metrics related to the language runtime, heaps, threads, all of that. And metrics related to the host environment, which is CPU, memory, and disk usage. Second up, we'll now look at the traces. So again, we'll go to the balance reader application, but this time we click on request histogram. And to correlate metrics to traces now, we'll use a feature called exemplars. To that, we'll click on options and just turn on exemplars. We'll have these tiny diamonds appended to our histogram right now. And we'll just click on one and query with Tempo. And there you go. Traces like these are presented to you. You can see exactly how much time each part of the entire request took. And digging into one of these sections will give you more information like database queries and HTTP headers, all of that. Now, if you need to drill even further, we'll now finally move on to logs. And to do that, we'll just, let's say, quickly copy this trace ID, and we'll go to Loki now. And let's just choose a namespace, the entirety of it for the sake of simplicity, and add a trace ID, and just run this query. And there you go. You have all the logs that you need related to this trace ID. You can use that to correlate what exactly a single request did end to end. And yeah, that is pretty much it. We've learned how easy it can be to extract and ship logs, traces, and metrics using only open source solutions. We were able to correlate between the different signals, and most importantly, we have all the data we needed to quickly detect and fix production issues in our target applications. But it doesn't end there. We will be able to detect and have all the data to diagnose and fix issues, but how do you approach incident management here for quicker resolution? So, an appropriately observable system is definitely a must for a quick resolution, but make sure that you don't lose the war against time during firefights due to human errors or miscommunication. And assess whether your organization could use an incident response tooling, just like Zenity, to keep response on the same page. Harness context-rich data from your observability plane that you so painstakingly set up, and enable your team to jump back from issues as fast as they can. And that's pretty much all my time. Thanks a lot for tuning in. I'm going to give back some time to you, and I hope that you're taking away something valuable away from the session. Feel free to reach out to me on Twitter or LinkedIn in case you have any questions, and have a great day.
Hey, hello everyone, and thank you for joining in. And there is another session around just a common uh, around the women in cloud native community, and the speaker is joining in 2 minutes, so we will wait for a few seconds. Yeah, I think she's here. Let me add her. So thank you for attending the long event. It's a weekend, I know. Probably everybody is want to enjoy the weekend. And thanks for the giving valuable time. And I'm going to add Nancy. She's going to talk about women in cloud native. So let me add first Sreya to introduce her.
So, thank you all for joining in the weekend, and I would like to thank our speaker Shubham Srivastava for the informative session on microservices observability. Next, we have Nancy Chauhan, who is going to speak on women in cloud native. So, yeah. Hi,
Yeah,
Nancy.
thank you so much, Shriya. You're doing amazing work as a host. Thank you so much. So I'm going to take 5 minutes or 10 minutes to tell about the new community. So I was discussing these things with my few friends. One of them is Sangam. We were talking you know, uh, about the diversity and inclusion in the cloud native space. And then we realized there are few problems where women are not much comfortable, or maybe they need a group of themselves where we can talk about how we can lift each other in cloud native space. And that's why there is one community, which is women in cloud native, which I and Vrikshali, she's not here, but yeah, so we founded it so that there's a space where we can discuss about new opportunities, how we can help each other. And it's open for all. Even open for everyone. There is no gender bias or something, but this is open for everyone, but a space where we encourage diversity, where we encourage learning together. So yeah, so I just wanted to talk about women in cloud native. And so there are So you can join this community. I'm just going to share my screen if you can present that. Shreya, yeah. Awesome. So I think, okay. Okay, so this is the website, which is Women in Cloud Native. We have like three core values, which is build and share. So there are a lot of things which are happening in the community itself. We build and share. There are so many projects which we together build. Then obviously we celebrate each other's accomplishment because we grow by lifting each other. Then there's support. That's why this, like, our community is committed to making cloud native a diverse space so that we can together help each other. Yeah, and I've just pasted this link of the article which was done by Cloud Native Computing Foundation itself about diversity. And there were few numbers. If you go through this article, there were few numbers of women, and that's why there were few number of women, as you can see, and that's why we created this community. So how you can contribute to this community? We have a Discord server which you can join if you are willing to join. It's okay if you don't want to join. We have Twitter, blogs, so you can just contribute there. We just want to create a space where all the contributions are more visible, and it's reachable to people. So we have this blog, and there are so many people who contribute to this blog, which is Women in Cloud Native, blog.womenincloudnative.com. So we put a lot of articles over here. Then we have started the YouTube live streaming, which happens every Thursday at 3 p.m. UTC. So right now we just had two live streams. One of them was about Kubernetes, how you can get started contributing to Kubernetes by Carol, and the another one was about AWS by my friend Sonia. So yeah, that's all we kind of do. And right now we are also running the 90 days of DevOps program. So pretty much a lot of things we are learning together. I just wanted to tell about that. We have this Twitter page, which is at the rate She Cloud Native, which you can find in my tagline as well. So yeah, that's all about the community. Thank you so much, Shreya, for sharing the screen and introducing me. Yeah.
Yeah, thank you for sharing with our audience. There is a community now. You can go ahead and contribute, and you can contribute blog. You can contribute anything you want. You can make a video. So same like our community, the goal is to empower everyone and have a diversity and support each other and help everyone. Maybe a student, maybe he's an engineer, you want to go career, connect socially, have a good kind of atmosphere in the and follow code of conduct as well. And thank you for sharing with our audience.
Yeah.
I
Thank you
give
for
a
having me.
few,
Yeah.
yeah, always welcome.
Yeah.
So a little bit around the new thing in CloudNativeFolks community, what's happening, what's the new updates. So one of the thing I started this newsletter, which is CloudNativeFolks newsletter. You can go there monthly. I'm gonna put up whatever I'm doing or whatever I wanna share with the people. There is no marketing stuff here, but I'm sharing, which is like valuable resource that every developer must learn, and everything is hands-on. Um, and as a new year revaluation, I thought there is there is no labs for container security. So I started, you can check it out, this link on the screen. You can go and practice the best container security practice, all hands on. And you can contribute also, it's open on GitHub. And you can see today's demos and everything is included all in detail. If you are new to the containers world also, you can go and learn the practice these labs, and you can learn by doing actually. And the last most, I want to thank you all the speakers, first of all, for giving valuable time. And there are speakers from different time zone, and first, and also thank you to all the audience for sitting with us and enjoying the conference. And also I want to thank our host Shreya for introducing all speaker, putting the efforts to contribute in the way of hosting. So this is a community. You can always join our Discord channel. Feel free to reach out me for anything. And this is the third non-profit DevOps India conference. I think you liked it. Feel free to subscribe to our YouTube channel for more such a conference and support such a free events. Thank you guys. Thank you for attending once again. And I will end this stream now.